Look up at the night sky on a clear evening, and you might see a handful of stars, but what if you could peer deeper? What if you could gaze beyond the limits of our eyes and witness not dozens, not thousands, but entire galaxies sprinkled like diamond dust across the infinite canvas of space? That's exactly what the Hubble Ultra Deep Field image gives us, a window into the profound and almost incomprehensible scale of the cosmos. It's more than a photograph. It's a tapestry of light, time, and mystery, each speck a galaxy unto itself, home to billions of stars and possibilities we're only beginning to imagine. This single image captures the essence of human curiosity, our timeless urge to explore, to understand, and to find meaning in the grandeur above us. But how do we make sense of something so vast, so beautiful, and at times so alien? For centuries, we've turned to two powerful ways of seeing the world: science and art. One seeks truth through data, measurement, and evidence. The other speaks to us through emotion, symbolism, and creativity. It might seem like these are separate paths, but what if they're not? What if the most meaningful interpretations of the universe happen when these two languages come together? That's where Deep Space Chronicles comes in, a journey into how art and science collaborate to translate the mysteries of the cosmos into something we can not only understand, but feel. This isn't just about facts and figures. It's about wonder, it's about connection, it's about seeing the universe not as a cold, empty void, but as a living story, full of drama, beauty, and meaning. In this video, we'll explore how artists and scientists work hand in hand to make the invisible visible and the unimaginable relatable. We'll see how visualizations of black holes, sonifications of distant stars, and even ancient star maps help bridge the gap between what we know and what we feel. You'll discover why this fusion of disciplines is more important now than ever, not just for expanding knowledge, but for helping us grapple with the biggest questions of existence. So settle in, open your mind, and get ready to see the cosmos in a whole new light. Because the universe isn't just something we observe, it's something we experience, interpret, and ultimately help bring to life through the stories we tell. Long before telescopes and satellites, humans looked up at the night sky with a mixture of wonder and practical need. This ancient relationship between humanity and the cosmos wasn't divided into separate disciplines of art and science. It was a single, unified effort to understand and record the world above. Some of the earliest evidence of this is found in cave paintings, like those in Lascaux, France, which are over 17,000 years old. Among the depictions of bulls and horses, scholars believe certain dot patterns and symbols represent star clusters like the Pleiades or major celestial events. These weren't just decorations, they were a form of proto-science. By artistically mapping the heavens onto cave walls, our ancestors were creating predictive calendars, tracking the migration of animals with the seasons, and using the stars to navigate their world. The act of observation and the act of creative representation were one and the same, a crucial tool for survival and the very beginning of astronomy. This beautiful synergy flourished throughout ancient civilizations. The Babylonians meticulously recorded the movements of planets on clay tablets. Their cuneiform script a blend of data and divine interpretation. In ancient Egypt, the ceiling of the tomb of Senenmut is a stunningly precise star chart, mapping out constellations and planets to guide the pharaoh's soul to the afterlife. The artwork is elegant and symbolic, yet its astronomical accuracy is undeniable. Even the great myths of the Greeks, like the story of Orion the hunter being placed in the sky, were often attempts to explain and personify the patterns they observed. These artistic narratives made the chaotic expanse of the night sky orderly, relatable, and memorable, transforming random points of light into a celestial storybook that could be passed down through generations. Perhaps no era better exemplifies the fusion of art and science than the Renaissance. This was a time when curiosity about the natural world was exploding, and individuals were not pigeonholed as solely artists or scientists. They were simply thinkers. The ultimate embodiment of this is Leonardo da Vinci. His notebooks are a breathtaking whirlwind of perfectly rendered human anatomy, detailed studies of water flow, designs for flying machines, and precise astronomical observations. For Leonardo, the act of drawing was the act of understanding. He believed that to truly know how a bird's wing worked, you had to draw it to capture its form and function with your own hand. This meticulous artistic observation was his scientific method. He didn't separate the beauty of a phenomenon from its mechanical principles. He saw them as two expressions of the same fundamental truth. This approach extended to the heavens. Renaissance artists and scientists were often one and the same person, using the latest advancements in perspective and chiaroscuro, the treatment of light and shadow, to depict the cosmos with newfound realism. They created volvels, intricate paper wheel charts that were both beautiful artworks and functional calculators for predicting eclipses and planetary positions. Their paintings of comets were not just dramatic spectacles, they were careful records of the comet's path, shape, and tail, providing valuable data for astronomers who would come later. A painting of a lunar eclipse from this period was as much a scientific document as it was a work of art, each brushstroke serving to document and decipher the mechanics of the universe. This historical intersection shows us that our desire to chronicle the cosmos is a fundamental part of being human, a timeless impulse to find meaning in the stars through both measurement and myth. But moving from the historical union of these disciplines, we arrive at a modern era where their partnership has become not just philosophical, but absolutely essential. Today, science often deals with realms that are utterly invisible to us, phenomena too distant, too massive, or too fundamentally alien for our senses to perceive. This is where art steps in, not as a mere accessory, but as a fundamental tool for translation. Think about a black hole, for instance. By its very definition, it's a region of space-time where gravity is so strong that not even light can escape. So how do you show the public something that, by its nature, cannot be seen? This was the monumental challenge faced by scientists when the Event Horizon Telescope collaboration set out to capture the first image of one. The raw data was a massive, complex set of radio wave measurements from telescopes scattered across the globe. Turning that into the now iconic image of the glowing ring of light surrounding a dark shadow required a tremendous amount of sophisticated algorithmic processing. But it also required artistic interpretation. Scientists collaborated with visual artists to decide on colorization, choosing that fiery orange and gold palette, not because that's its true color, but because it effectively conveys the intense heat and energy of the superheated plasma swirling around the event horizon. This visualization is a masterpiece of scientific communication. It takes an abstract mathematical concept and transforms it into a tangible, emotionally resonant image that anyone can understand and be awestruck by. It's a perfect example of art acting as a universal language for science. This process of translation is everywhere in astronomy. Consider exoplanets, worlds orbiting stars light years away. We can't photograph them in any detail. We infer their existence through tiny dips in a star's brightness or slight wobbles in its motion. From that scant data, scientists can calculate a planet's mass, its orbit, and even the composition of its atmosphere. But to bring that world to life, we turn to artists. These illustrators, often working in close consultation with astrophysicists, use the scientific data as their blueprint. They take the known facts: this planet is a gas giant, it orbits very close to its star, its atmosphere contains sodium and titanium oxide, and use the principles of physics, chemistry, and light to paint a plausible picture of what it might look like to be there. The swirling bands of a gas giant's atmosphere, the haunting glow of a nearby nebula, the sharp shadows cast by a binary star system, these artistic renderings do more than just excite the imagination. They make the science real. They allow us to connect with these distant discoveries on a human level, fostering a sense of wonder that a simple graph of data points could never achieve. Perhaps no single image better demonstrates the dual power of art to communicate science and inspire inquiry than the Hubble Space Telescope's Pillars of Creation. Originally captured in 1995, this photograph of towering columns of interstellar gas and dust in the Eagle Nebula is instantly recognizable. But it's crucial to understand that this image itself is a form of artistic interpretation. Hubble doesn't see color. It captures light through specific filters that isolate the emission from particular elements like sulfur, hydrogen, and oxygen. Scientists then assign colors to these different wavelengths, often, but not always, choosing a palette that represents their actual energy levels to create the final composite. The result is not a literal snapshot but a translated, enhanced visualization. Yet its impact is immeasurable. It didn't just communicate the existence of a stellar nursery. It became a cultural touchstone, appearing on posters, album covers, and T-shirts worldwide. It evoked a sense of sublime grandeur and creative destruction, showing us where stars are born and where they die. Furthermore, its artistic clarity had a direct scientific benefit. The incredible detail visible in the pillars prompted new questions and closer analysis. Later observations with Hubble's more advanced cameras revealed subtle changes in the structures over time, allowing scientists to study the shockwaves from a nearby supernova and better understand the dynamic and violent life cycle of these cosmic landmarks. In this way, the art didn't just follow the science, it actively guided it, helping researchers see their data in a new light and ask questions they might not have otherwise considered. While scientists use data to build models and test theories, artists use that very same information as their raw material, their pigment, their musical scale to compose entirely new experiences of the cosmos. This is where the journey of data transcends spreadsheets and becomes something deeply human. It begins with the vast streams of information collected by our mechanical eyes and ears on Earth and in space, the faint whispers of radio waves from a dying star, the precise light curves of a distant exoplanet crossing its sun, or the intricate spectral lines that reveal the chemical fingerprint of a nebula millions of light years away. To a researcher, this is a dataset ripe for analysis, but to an artist like Leah Halloran, it's a blueprint for a masterpiece. She takes the complex structures of celestial objects, from the delicate filaments of a supernova remnant to the grand spiral arms of a galaxy, and uses them to create enormous cyanotypes. This 19th century photographic process, which produces those beautiful deep blue and white prints, becomes a bridge across time. She's essentially using sunlight to capture the forms of distant suns, translating digital astronomical data into tangible, physical artworks that you can walk beside and feel dwarfed by, mirroring the actual scale and awe of the universe itself. Her work, like the series Your Body is a Space That Sees, doesn't just show you a galaxy, it lets you stand in its presence, creating an emotional and physical connection that a graph or chart could never foster. But the interpretation of cosmic data isn't confined to the visual realm. What does a star sound like? It's not a silent question anymore, thanks to the fascinating field of data sonification. Musicians and scientists are collaborating to assign sonic values to scientific information, turning light, radiation, and gravitational waves into symphonies from space. Composer John D. Boswell, under his project Symphony of Science, and through his channel Melodysheep, has become a pioneer in this area. He takes the data from sources like NASA Chandra X-ray Observatory or the Kepler spacecraft and maps the numerical values onto musical notes. Perhaps pitch represents brightness, duration represents distance, or a specific instrument represents a type of elemental emission. The result is not just random noise, it's a haunting, often beautiful, and strangely moving composition. You can listen to the radar echoes from Titan's methane lakes transformed into a pulsing, atmospheric rhythm, or hear the light curve of a star with orbiting planets become a melodic sequence with a distinct, repeating dip, the audio signature of a world passing in front of its sun. This process does more than create interesting music. It offers a new mode of discovery. Our ears can sometimes detect patterns, a subtle rhythm, an anomaly, a harmony that our eyes might overlook in a visual plot. Sonification becomes an analytical tool, allowing researchers to literally hear the data, adding a new dimension to their exploration. This multi-sensory approach to astronomy fundamentally changes our relationship with the universe. It acknowledges that we are not purely logical beings. We are emotional, sensory creatures who learn and connect through sound, touch, and sight. When an artist sculpts the form of a dark matter distribution based on gravitational lensing data, or when a digital animator builds a flight through the Large Magellanic Cloud using actual stellar positional data, they are building a bridge. They are translating the language of mathematics into the language of human experience. These artworks and soundscapes don't replace the science, they complement it and enrich it. They allow us to not just know about a quasar or a neutron star collision, but to, in some small way, experience it. They provide an emotional layer to the intellectual pursuit, fostering a sense of wonder and connection that is absolutely vital for public engagement and support. This creative alchemy, turning raw data into artistic expression, proves that the universe is not just a collection of facts to be learned, but a profound source of inspiration to be felt. Yet this translation from data to experience requires more than just accurate visuals or sounds. It demands a shared language, a way to grasp concepts so vast and alien that they defy our everyday understanding. This is where the power of metaphor and symbolism becomes indispensable, a tool wielded by both scientists and artists to build bridges between the human scale and the cosmic infinite. Consider the terms we use so commonly in astronomy: the cosmic web, a phrase that paints a picture of galaxies strung along invisible filaments of dark matter like dewdrops on a spider's silk. Or a stellar nursery, which immediately conjures an image of a warm, protective, and generative space where new stars are born from clouds of gas and dust. These aren't just clever nicknames, they are fundamental cognitive tools. They take a terrifyingly abstract idea, the large-scale structure of the universe or the process of star formation, and wrap it in a familiar, almost domestic concept. A web is something we can understand. A nursery is a place of care and beginnings. These metaphors do the heavy lifting of comprehension, allowing us to hold these colossal ideas in our minds by connecting them to things we already know from our own world. They make the universe feel less like a cold, mechanical void and more like a place with patterns and processes we can recognize, even on a human level. Artists deeply explore this territory, using symbolism to create a profound emotional and philosophical dialogue with the cosmos. Take the work of Vija Selmans, for instance. Her canvases are not fantastical renderings of nebulae. They are painstakingly meticulous, monochromatic recreations of the night sky based on astronomical photographs. She will spend months on a single drawing, replicating the precise speckle of stars against a dark field. The power of her work lies in its intense focus and quiet intimacy. By bringing the infinite down to the scale of a handheld piece of paper, and by investing such profound human time and labor into its recreation, she creates a powerful symbol. Her art becomes a meditation on our relationship with the universe, on the act of looking itself, on the immense distance between us and the stars, and on the poignant human desire to capture and possess that which is forever out of reach. She uses the symbol of the starfield not to explain it, but to make us feel our own smallness and our own connection simultaneously. It transforms astronomical data into a deeply personal and emotional experience. This symbolic language extends far beyond the canvas into the very poetry of scientific communication. When an astronomer describes a nebula not just as a cloud of ionized gas, but as a waltz of light and matter, or refers to the redshift of distant galaxies as the universe stretching its limbs, they are engaging in the same act of narrative creation. These poetic descriptions are more than flowery language. They are essential for building meaning. They take the cold, hard fact of the Doppler effect and give it a story, a sense of motion and life. This symbolic framing turns a catalogue of objects into an epic saga of birth, life, and death on a galactic scale. A supernova isn't just a stellar explosion. It's a fiery death that seeds the cosmos with the heavy elements necessary for planets and life. This symbolism enriches our dialogue with the cosmos, providing not just information but also context and significance. It answers the what with a suggestion of the why, allowing us to see the universe not as a random collection of events but as a coherent, if incredibly complex, narrative in which we are somehow participants. This shared language of metaphor, built by artists and scientists together, is what truly turns data into understanding and facts into connection. This human need to map the heavens, to impose order on the chaos of the night sky, is one of our most enduring intellectual and artistic endeavors. It's a practice known as celestial cartography, and its history is a perfect case study of art and science walking hand in hand. The earliest star maps were not just functional guides, they were profound cultural narratives painted across the canvas of the night. Ancient cultures, from the Greeks to the Chinese, from the Polynesian navigators to the Druids, all looked up and saw different patterns. They connected the dots of starlight into shapes that reflected their myths, their gods, their animals, and their understanding of the cosmos. These constellations were a fusion of careful observation and powerful storytelling. The star pattern we call Orion was, to the ancient Egyptians, the god Sa, and to the Aboriginal Australians, a group of young men dancing. Each map was a cultural artifact, a beautiful and artistic expression of a people's place in the universe, drawn with whatever tools they had, ochre on cave walls, ink on parchment, or memory passed down through song and story. The invention of the telescope and the precise instruments of the Renaissance didn't eliminate this artistic spirit. It simply gave it new tools and a new standard of accuracy. This period produced some of the most breathtakingly beautiful celestial atlases ever created, where scientific precision and artistic grandeur were given equal weight. The pinnacle of this era is undoubtedly Johann Bayer's Euronometria, published in 1603. This monumental work was the first to systematically cover the entire celestial sphere, and it introduced a naming convention for stars, using Greek letters combined with the constellation name, like Alpha Centauri, that we still use today. But its true legacy is its art. Bayer commissioned master engravers to create the charts, and each constellation is depicted not as a simple connect-the-dots diagram, but as a vibrant, dynamic figure. Orion is a heroic hunter, his arm raised, his sword at his belt, set against a background of precisely positioned stars. The figures are richly detailed, almost leaping off the page, yet the star positions themselves were the most accurate of their time. The Euronometria wasn't just a catalogue, it was a masterpiece that celebrated the sublime beauty of the heavens, proving that a map could be both scientifically rigorous and a work of profound art. It set a standard that influenced astronomers and artists for centuries. That artistic tradition didn't fade with the advent of modern science, it evolved. Today, our celestial cartography is digital, dynamic, and three-dimensional. Projects like the European Space Agency's Gaia mission are creating an unprecedented map of our galaxy, precisely charting the positions, distances, and motions of over 1 billion stars. But this raw data, this immense catalogue of numbers, needs to be interpreted to be understood. This is where the modern celestial cartographers come in, data visualizers and artists who take these trillion-byte datasets and turn them into something we can see and explore. They create stunning three-dimensional models of the Milky Way that we can fly through in planetarium shows or interactive online applications. They use color to represent a star's temperature, its age, or its velocity. These modern maps are no less artistic than Bayer's engravings. The medium has simply changed from copperplate to code. The creative choices are still there. Which angle to view the galaxy from, which data to highlight, which color palette to use to most effectively tell the story of the data. A visualization of the Gaia data revealing the galaxy's past collisions and the subtle ripples in its disk is every bit as awe-inspiring as a hand-drawn atlas, because it uses the artist's toolkit, composition, color, and form, to reveal a hidden truth about our cosmic home. From the earliest sketches in the dirt to the most complex digital simulation, celestial cartography has always been about more than just plotting points. It is a fundamental human impulse to navigate, to understand, and to find beauty in the patterns of the cosmos. These maps are mirrors, reflecting not only the state of our scientific knowledge, but also our cultural values and our boundless creativity. They chart the unknown for explorers, providing the literal guidance that sent sailors across oceans and will one day send spacecraft between stars. And they inspire the dreamers, offering a vision of the universe that is both intellectually satisfying and soul-stirringly beautiful. They are a perfect testament to the idea that to truly chronicle the cosmos, we need both the precision of the scientist and the vision of the artist. This evolution from two-dimensional maps to fully immersive worlds represents the next great leap in how we chronicle the cosmos. We are no longer just looking at space, we are stepping into it, thanks to the revolutionary power of digital art, virtual reality, and augmented reality. These technologies are fundamentally transforming our engagement with the universe, dissolving the barrier between observer and participant. Imagine not just seeing a photograph of the Martian surface, but actually standing on it, your digital feet crunching on the rust-colored regolith as you look up at a pale pink sky and the tiny sun hanging in the distance. Or consider the privilege of witnessing a supernova explosion not as a fleeting dot on a graph, but from a virtual ringside seat, watching in awe as a star's final, cataclysmic death unleash waves of light and energy all around you. This is the profound shift brought about by VR and AR. They trade passive observation for active, embodied experience, making the scale and drama of the cosmos something we can feel in our bones. This isn't science fiction. It's happening right now through incredible projects that merge rigorous scientific data with cutting-edge creative technology. NASA Eyes on the Solar System is a perfect example, a sophisticated software platform that is essentially a real-time, interactive universe simulator. It doesn't use guesswork. It pulls directly from the trajectory data and telemetry of dozens of active missions. You can zoom in from a galactic view all the way down to see the exact position of the Juno spacecraft as it orbits Jupiter, or track the Perseverance rover's path across Jezero crater. But it's the artistic interpretation that makes this data come alive. Digital artists and visualizers use the real numbers to build stunningly detailed three-dimensional models of the planets, their atmospheres, and their spacecraft. The swirling clouds of Jupiter aren't a generic animation. They are based on actual meteorological data. The lighting on the rings of Saturn is calculated accurately based on the position of the Sun. This creates an experience that is both scientifically authentic and visually breathtaking, allowing anyone with a computer to become a virtual astronaut and explore the solar system from their desk. It's a powerful educational tool that makes complex orbital mechanics and mission objectives intuitively understandable simply by letting you fly alongside the probes themselves. The experience becomes even more powerful and emotionally resonant when you leave the desktop behind and fully immerse yourself in a headset. Planetariums and museums around the world are now creating breathtaking VR installations that are equal parts art exhibit and scientific visualization. One might let you stand on the surface of an exoplanet, looking up at an alien sky with multiple moons and a strange, pulsing nebula dominating the heavens. Another might take you on a journey from the quantum scale up to the cosmic web, a dizzying, poetic trip through the scales of the universe. These are not dry documentaries, they are carefully crafted narratives. They use music, sound design, and expertly paced visual storytelling to evoke specific emotions, a sense of wonder, of humility, of profound connection. The artistic choices in color, scale, and movement are critical to conveying the emotional truth of these phenomena, even as the underlying shapes and distances are scrupulously accurate. This fusion of fact and feeling is what makes these experiences so memorable and impactful. They teach you not just what something is, but what it feels like. This democratization of access is perhaps the most important cultural shift. You no longer need a PhD in astrophysics or $1 million for a ticket on a future spaceflight to have a personal, meaningful encounter with the cosmos. A student in a classroom in Nairobi can take a VR walk on the moon. A grandparent in Lima can don a headset and witness the birth of a star. These technologies are breaking down the financial and physical barriers that have always made space feel like an exclusive domain for governments and elite scientists. By making these experiences more accessible, they are fostering a global sense of ownership and curiosity about space exploration. Furthermore, this technology is redefining the very nature of our chronicles. Our records of cosmic journeys are no longer confined to technical papers, photographs, and grainy video. They are becoming immersive archives. We can now create a permanent, interactive record of the Apollo 11 landing site that future generations can visit, or a precise digital twin of the Hubble Space Telescope that you can float around and examine from every angle. We are chronicling the universe not just with words and pictures, but with entire worlds, preserving our discoveries in a rich, multi-sensory format that conveys their true majesty and scale in a way a textbook never could. And this transformation of public perception through powerful imagery has a very real and tangible impact, one that echoes through the halls of government and directly into the budgets that determine our future in space. It's a fascinating cycle. A stunning piece of space art captures the public's imagination. That collective wonder translates into popular support, and that support becomes the political capital needed to fund the next great mission. Perhaps no single photograph in human history demonstrates this power more than Earthrise, taken by astronaut William Anders during the Apollo 8 mission in 1968. It wasn't a planned shot. The crew was actually focused on mapping the lunar surface when they suddenly saw it, their home planet, a fragile, brilliant blue and white marble, rising over the barren, gray horizon of the moon. The image was immediately and profoundly transformative. It was splashed across magazine covers and television screens worldwide, becoming an instant icon. For the first time, humanity saw itself not as continents and countries divided by borders, but as a single, beautiful, and isolated world floating in the immense blackness of space. This artistic accident, this unplanned composition of overwhelming beauty, became the ultimate symbol for the budding environmental movement. It gave emotional weight to the concept of spaceship Earth and our shared responsibility to protect it. That single image did more to change our global self-perception than 1,000 scientific papers could have, and it cemented public approval for the space program at a critical time, showcasing its value not just for exploration, but for offering a new perspective on ourselves. This tradition of the iconic image driving public engagement continues powerfully into the modern era, but the tools and the speed of dissemination have changed dramatically. The first official image of a black hole, released by the Event Horizon Telescope collaboration in 2019, is a perfect example for the digital age. The scientists knew they had a monumental discovery, but they also understood its abstract nature. A blurry orange donut of light against a dark background doesn't immediately scream groundbreaking science to a layperson. So they invested heavily in the release of the image, treating it like a global premiere. They coordinated press conferences on multiple continents simultaneously, created sleek explanatory videos and animations, and provided a clear, compelling narrative around the decades of work it took to achieve this. The result was a media firestorm. The image went viral within minutes, becoming the subject of countless memes, news segments, and social media posts. It was everywhere. This wasn't just about the science, it was about the sheer awe of seeing the unseeable. That glowing ring became a symbol of human ingenuity and perseverance. It made the incredibly complex science of general relativity and interferometry accessible, and more importantly, shareable. People who had never given a thought to black holes were suddenly talking about event horizons and gravitational lensing. This massive wave of public excitement and positive press doesn't just feel good for the scientists. It demonstrates to the politicians who control funding agencies that space science captures the public's imagination and is worth investing in. It provides undeniable proof that these ambitious, expensive projects return a huge dividend in global cultural capital and inspiration. This connection between art, public support, and funding is often strategically cultivated through deliberate campaigns. NASA, for instance, has long understood that its greatest ambassador isn't always an astronaut, it's often an artist or a stunning visual. The agency's art program, which dates back to the 1960s, has commissioned painters like Norman Rockwell and Robert McCall to interpret the space program, creating heroic and optimistic visions of exploration that shaped the public mood of the space age. These artworks were used in magazines, on posters, and in television specials to build excitement and make the future of spaceflight feel tangible and inevitable. In the modern day, this has evolved into a mastery of social media. NASA Instagram and Twitter accounts are curated galleries of cosmic art, from the swirling violet and gold clouds of the Carina Nebula captured by the James Webb Space Telescope to the hauntingly beautiful pale blue streak of a comet's tail. Each post is crafted not just to inform, but to evoke an emotional response, a sense of wonder, curiosity, or sheer beauty. They encourage people to download these images as phone wallpapers, to share them with friends, and to see themselves as part of this journey of discovery. This constant positive engagement builds a massive, dedicated community of supporters, and that community is a powerful advocacy group. When budget discussions come up in Congress, constituents write letters and make calls, advocating for continued funding for NASA because they feel a personal connection to the incredible journey those images represent. The art creates the connection fuels the advocacy, and the advocacy helps secure the funding for the next telescope, the next rover, the next mission that will produce the next generation of breathtaking art. It's a virtuous cycle that turns pixels and paint into political will, ensuring that our chronicle of the cosmos can continue for generations to come. Yet this immense power to inspire and shape perception through art comes with a profound ethical responsibility. When we visualize the cosmos, we are not just creating pretty pictures, we are interpreting reality, and often, we are depicting the only version of a distant world or a complex phenomenon that the public will ever see. This act of representation carries a significant weight for both the scientist and the artist, a duty to navigate the delicate balance between wonder and accuracy, between sparking imagination and avoiding outright misinformation. The core of the ethical challenge lies in the vast unknowns. Space is filled with phenomena we don't fully understand, from the true nature of dark matter to the potential forms of alien life. How do you represent something honestly when so much of it is, by definition, a mystery? The answer lies in a practice of radical transparency about the limits of our knowledge. An ethical visualization will often make a clear distinction between what is known, what is inferred based on solid scientific principles, and what is purely speculative artistic license. For instance, a responsible artist depicting an exoplanet will base the color of the sky on the known composition of its atmosphere and the type of its star, but they might openly state that the design of any hypothetical plant life is entirely an imaginative exercise. This honesty doesn't diminish the wonder, it enhances the viewer's appreciation for the real science while still allowing the art to dream. The line between inspiration and sensationalism is another critical ethical frontier. There's a temptation, especially in media aimed at generating clicks or views, to push depictions into the realm of the dramatic and the terrifying. Imagine an article about a nearby asteroid. A responsible visualization might show its accurate size and trajectory in relation to Earth, perhaps with a small, labeled diagram. A sensationalized version, however, might show a gigantic, pockmarked rock looming over a terrified city, with flames streaking across the sky. While undoubtedly attention-grabbing, this kind of imagery preys on fear rather than fostering understanding, and it can contribute to public misinformation and unnecessary anxiety about real astronomical events. The ethical approach is to prioritize context and scale, ensuring that the artwork or graphic serves to educate and illuminate rather than to alarm and distort. The goal should be to convey the genuine awe of the situation, the incredible precision of orbital mechanics that allows us to track such objects, and the fascinating insights they provide into our solar system's history without resorting to apocalyptic fiction. This responsibility extends beyond mere facts into the realm of cultural and environmental perspectives. As we begin to visualize other worlds, we must be acutely aware of the cultural baggage we might inadvertently bring with us. Depictions of space colonization, for example, often echo the themes of historical frontier expansion on Earth, showing pristine, untouched worlds ready for human settlement and resource extraction. This narrative can be deeply problematic, carrying echoes of colonialism and ignoring the profound ethical questions about our right to alter or exploit other planets. An ethical representation might instead frame colonization through a lens of stewardship and extreme caution, considering concepts like planetary protection, which aims to prevent biological contamination of other worlds, and the intrinsic value of preserving extraterrestrial environments in their natural state, even if they don't contain life as we know it. It encourages us to ask not just can we settle there, but should we, and if so, how can we do it responsibly? Nowhere is this ethical tightrope more precarious than in the depiction of alien life. This is the ultimate exercise in representing the unknown. For decades, science fiction has largely presented us with humanoid aliens bipedal, with a head, 2 eyes, and a familiar body plan. While this makes them relatable for storytelling, it is a profound failure of imagination from a biological standpoint and can set unrealistic public expectations. An artist or scientist ethically considering this problem would ground their speculation in the science of astrobiology. They might consider the potential biochemistry of life on a moon with liquid methane seas, leading to creatures with silicone-based biology and utterly unfamiliar forms. They might envision a planet with high gravity giving rise to low, sturdy life forms, or a world with a perpetual twilight, fostering life that navigates through sound rather than sight. The most responsible depictions of aliens will often look nothing like us, challenging our anthropocentric view of life itself. They acknowledge that the universe, in its creativity, is likely far stranger and more wonderful than our most familiar fantasies. By choosing to visualize aliens that are truly alien, we do more than just create interesting art. We prepare the public mind for the genuinely unexpected nature of discovery, fostering a sense of curiosity that is open to any possibility rather than one that expects little green men. This thoughtful, ethically informed approach ensures that our chronicles of the cosmos are not only beautiful, but also built on a foundation of integrity and respect for the profound mysteries we have yet to solve. These groundbreaking partnerships are far more than just a scientist hiring an artist to make a pretty picture. They are deep, reciprocal relationships where each discipline fundamentally challenges and enriches the other. At the heart of this collaboration is a beautiful exchange of languages. The scientist brings the data, the theories, the hard numbers that describe how the universe works. The artist brings the intuition, the emotional resonance, and the creative techniques to explore what that universe means and how it feels. When an astronomer sits down with a sculptor, they aren't just providing a blueprint. They are entering a dialogue where the artist questions, why is this important? Or what would it feel like to touch this? Force the scientist to explain their work in new ways, often leading to fresh perspectives on their own research. Conversely, the scientist's rigorous constraints push the artist beyond cliché and into new realms of creative expression, grounded in a reality more astonishing than any pure fantasy. This cross-pollination doesn't just produce a final artwork, it reshapes the thinking of everyone involved, fostering a culture of boundless curiosity that is essential for true innovation. We can see this powerful synergy in action through formal programs designed to foster these very connections. The SETI Institute's Artist in Residence program is a perfect example. SETI, the search for extraterrestrial intelligence, deals with one of the most profound and inherently speculative questions we can ask: are we alone? This question is as much philosophical and cultural as it is scientific. By bringing in artists, composers, painters, writers, and filmmakers, the Institute injects these deep humanistic questions directly into its scientific environment. An artist might compose a piece of music based on the mathematical structure of a signal that could be from an intelligence, giving a tangible, emotional weight to the abstract concept of contact. Their work doesn't just communicate SETI science to the public, it helps the scientists themselves reconnect with the profound wonder and emotional stakes of their own mission, reminding them that they are searching not just for data, but for a paradigm-shifting revelation about our place in the cosmos. Similarly, the arts program at CERN, the European Organization for Nuclear Research, is legendary for its profound impact. CERN is home to the Large Hadron Collider, where physicists probe the most fundamental building blocks of reality, dealing with concepts like quantum fields and extra dimensions that are completely divorced from human sensory experience. Their data is often just lines on a graph. By hosting artists for extended residencies, CERN allows creators to immerse themselves in this rarefied world. The artists are given remarkable access to the labs, the tunnels, and, most importantly, the minds of the physicists. A sculptor might spend months talking with a researcher about the Higgs boson, not to build a literal model of the particle, but to capture the essence of its behavior, its fleeting existence, its role in granting mass to the universe. The resulting artwork becomes a translation, a sensory interpretation of a deeply abstract idea. For the public, it's a way to grasp the ungraspable. For the scientists, it can be a revelation, offering a new metaphorical lens through which to view their own work, sometimes even sparking new ways of thinking about a persistent problem. The collaboration proves that the questions of art and science are ultimately the same. What is this made of? How does it behave? Why does it matter? They simply use different toolkits to seek the answers. The outputs of these partnerships are as diverse as the disciplines involved, and they often defy easy categorization. They are not scientific illustrations, nor are they purely abstract art. They exist in a fertile middle ground. Consider the work of the artist Annika Yi, who collaborated with molecular biologists and chemists to create installations exploring the nature of smell, evolution, and intelligence. Her work, while not directly about space, embodies the same interdisciplinary spirit, using scientific processes as her medium. Or take the collaborative projects between NASA and contemporary musicians, where data from the Juno mission to Jupiter is sonified into eerie, beautiful symphonies that let us hear the giant planet's magnetic field. These creations are more than the sum of their parts. They are unique objects and experiences that could not have been conceived by a scientist or an artist working in isolation. They stand as testaments to the idea that the biggest questions about our universe and our existence within it cannot be answered by one way of knowing alone. They require the full spectrum of human curiosity, from the precise logic of the experiment to the intuitive leap of the creative act, working in concert to push the boundaries of what we can discover and express. There's a reason why a single image of a distant nebula or a simulation of the Big Bang can leave us utterly speechless, caught in a moment of profound stillness. It's more than just recognizing something beautiful or intellectually impressive. It's a deep, visceral reaction that psychologists have a specific name for: awe. Awe is that complex emotion we feel in the presence of something vast that transcends our current understanding of the world, something that dramatically expands our way of seeing things. It's the feeling of being humbled and connected all at once, a sense of smallness that paradoxically doesn't make us feel insignificant, but rather part of something much larger than ourselves. And when it comes to triggering this powerful response, few subjects are as potent as the cosmos. The sheer scale of a galaxy, the violent beauty of a star's death, the mind-bending concept of infinite expansion. These ideas are so far beyond our everyday experience that they can literally shift our perspective. This isn't just a poetic notion, It's a robust field of scientific study. Researchers in positive psychology, like Dasha Keltner at the University of California, Berkeley, have conducted numerous studies showing that experiences of awe have measurable, beneficial effects on our minds and bodies. They found that feeling awe can slow our perception of time, making moments feel more rich and expansive. It can make us more curious, more creative, and less focused on our own individual concerns. In one famous experiment, participants who stood and gazed up at a grove of towering eucalyptus trees for just 1 minute were subsequently more helpful, more ethical, and more generous to others than participants who looked at a tall building. The awe experience seemed to diminish their sense of self-importance, making them more inclined to act as part of a community. Now, translate that from a California grove to the edge of a black hole or the birth of a universe in a planetarium show. The stimulus for awe is magnified 1 billion times over, suggesting that cosmic art isn't just a passive representation. It's an active tool for cultivating some of our most pro-social and positive human traits. This is the secret power behind the most impactful Deep Space Chronicles. They are engineered, whether consciously or not, to be delivery systems for awe. An artist choosing the palette for a nebula isn't just picking pretty colors. They are amplifying the vastness and the ethereal quality of the gas clouds to trigger that sense of wonder. A composer sonifying the data from a pulsar isn't just making music. They are translating the relentless clockwork rhythm of a dying star into a sound that can evoke a feeling of sublime majesty. A visualizer creating a flight through the Orion Nebula in virtual reality isn't just building a model. They are constructing an experience designed to make you feel like you are there, to give you that visceral, gut-level understanding of scale that a textbook paragraph about trillions of miles simply cannot convey. These artworks succeed because they tap into this ancient psychological wiring, offering us a safe and accessible way to stand at the edge of the infinite. Ultimately, this helps us understand why the human drive to create and consume cosmic art is so enduring and so universal. It answers a deep psychological need. In our modern, daily lives, our attention is often dominated by a narrow focus on our immediate needs, our schedules, and our screens, a state psychologists call the small self. Cosmic art, in all its forms, is a powerful antidote to that constrained view. It forcibly pulls us out of that smallness and confronts us with the breathtaking grandeur of the universe. This experience doesn't belittle our existence, it recontextualizes it. Our personal worries don't vanish, but they are placed within a framework so immense that it can reduce their weight, offering a profound sense of perspective and calm. This is why chronicles of the cosmos are far more than intellectual pursuits or beautiful distractions. They are a form of vital nourishment for the human spirit, a necessary reminder of our place in a stunning, mysterious, and awe-inspiring universe, and a catalyst for making us more curious, more connected, and more humane. This powerful fusion of art and science isn't just transforming how we experience the cosmos as adults. It's also completely reshaping how we introduce the universe's grandest mysteries to the youngest minds. Educational outreach has discovered that to teach the most complex ideas in astronomy, you don't always need a textbook or a complex equation. Sometimes, the most effective tool is a paintbrush, a story, or a song. The challenge of explaining something like Einstein's theory of relativity to a child is monumental. Concepts like the warping of space-time are inherently abstract and counterintuitive. But an animated video can show it. Imagine a short cartoon where a bowling ball is placed on a stretched rubber sheet, causing a deep indentation, and then a marble is sent rolling around the curve, orbiting the larger mass. This simple, elegant visual analogy, a work of art in motion, conveys the fundamental principle of gravity warping space in a way that a 10-year-old can not only understand but also remember. It turns an intimidating theory into a tangible, relatable story. This philosophy is at the heart of incredible global initiatives like Universe Awareness or UNOR. This program is specifically designed for children aged 4 to 10, particularly those from underprivileged backgrounds, and its entire methodology is built on the idea that art and storytelling are universal gateways to wonder. UNOR doesn't start with facts and figures, it starts with the oldest human traditions. Children in different countries might learn about the constellations by listening to the ancient Greek myths behind them, then go outside and create their own star patterns and invent their own stories to explain them. They might use colorful clay to model the solar system, getting a physical, hands-on sense of the different sizes and distances of the planets. They might sing songs about the phases of the moon or put on a play about the life cycle of a star. Through these creative activities, the vast, often intimidating universe becomes a friendly place of imagination and play. The science is woven seamlessly into the art. By building a model of the solar system, a child intuitively learns about orbital order and planetary characteristics. By drawing what they think an alien might look like on a world with high gravity, they are unknowingly engaging with the principles of biology and evolution. This approach proves that art doesn't dumb down the science, it makes the science stick, creating foundational memories and understandings that can spark a lifelong passion. The reach of this artistic approach to education has exploded with the digital age, moving far beyond the classroom wall. Online platforms like YouTube and TikTok are filled with creators who are masters of this craft. Channels like Kurzgesagt in a nutshell use stunning, minimalist animation and a warm, friendly narration to break down terrifying concepts like black holes or the Fermi paradox into digestible and strangely comforting visual essays. Their art style is instantly recognizable: clean lines, friendly bird characters, and a palette of soothing colors that make even the end of the universe feel approachable. Similarly, comic artists like Randall Munro of XKCD or the creators of the webcomic Saturday Morning Breakfast cereal frequently use humor and simple line drawings to illustrate brilliant scientific puns or thought experiments, making complex ideas shareable and relatable for a massive online audience. These aren't just lectures with pictures, they are full artistic productions where the animation, the music, the pacing, and the script all work in concert to create an emotional and intellectual experience. A student might struggle to grasp dark matter from a dense paragraph in a book, but a 5-minute video that portrays it as an invisible, gravitational scaffolding holding galaxies together, illustrated with glowing, ethereal networks, can make the concept click in an instant. This artistic breaking down of barriers is perhaps the most significant outcome of this educational shift. Topics that were once considered too difficult for young audiences or for those without a strong math and science background are now being opened up to everyone. A beautifully illustrated graphic novel about the James Webb Space Telescope can captivate a reluctant reader and pull them into the world of astrophysics. A virtual reality experience at a museum that lets you stand on the surface of Mars can inspire a child who never saw themselves as a scientist. By translating data into drama and principles into paintings, we are democratizing cosmic knowledge. We are sending a powerful message that the conversation about the universe isn't reserved for those with advanced degrees. It is a human birthright, a story that belongs to all of us. This approach invites diverse voices and perspectives into astronomy, fostering a new generation of thinkers who may approach problems with both analytical rigor and creative flair. ensuring that the future of space exploration is as rich and varied as the cosmos itself. As we stand on the cusp of a new era in space exploration, the very tools we use to chronicle the cosmos are undergoing a revolution that will redefine the relationship between artist, scientist, and audience. The future of Deep Space Chronicles is not just about sharper images or more data. It's about a fundamental shift in how we create, share, and even physically interact with our interpretations of the universe. Artificial intelligence is already stepping out of its role as a mere tool for data analysis and becoming a creative partner in its own right. We're seeing the rise of generative AI models that can be trained on thousands of astronomical images, learning the underlying physics and aesthetics of nebulas, galaxy collisions, and star formation. An artist or scientist can then provide a prompt, perhaps a description of an exoplanet's atmosphere based on spectral data, and the AI can generate a stunningly plausible visualization of that world's skies, not from scratch, but from a deeply learned understanding of atmospheric physics, light scattering, and cosmic aesthetics. This doesn't replace the human artist. It amplifies their capabilities, allowing them to rapidly prototype ideas and explore visual possibilities that would take months to paint by hand, all while staying grounded in scientific principle. This collaborative creation between human intuition and machine learning will lead to a new genre of space art that is both wildly imaginative and rigorously plausible. The way we experience these chronicles is also set for a quantum leap beyond the screens and headsets of today. Imagine walking into a room where a holographic display renders the Cassini mission's entire journey through the Saturnian system in exquisite detail, not as a flat animation, but as a three-dimensional sculpture of light and data that you can walk around and view from every angle. These aren't the faint, bluish holograms of science fiction. We're talking about photonic systems that use precisely controlled lasers to trap and illuminate tiny particles in mid-air, creating solid-looking images that float in space. You could reach out and seemingly touch the rings of Saturn, watching particles of ice and rock swirl around your fingers, or witness a supernova explosion unfold as a shimmering sphere of light expanding slowly in the center of the room. This technology will move us from passive observation to active, embodied exploration within our own homes and museums, making the scale and dynamics of cosmic phenomena tangibly real in a way that fundamentally alters our perception. Perhaps the most profound frontier lies in the realm of bioart, where the very materials of life become our medium for cosmic expression. As we begin to retrieve samples from asteroids, Mars, and the moons of the outer solar system, we will gain access to entirely new palettes of extraterrestrial materials. Artists will not just paint pictures of Mars, they will create with Martian regolith itself, mixing the iron-rich red dust into paints and ceramics to craft artifacts that are literally of another world. We might see bio-artists using extremophile bacteria discovered in the briny waters of Enceladus to create living canvases that change and grow under different environmental conditions. Their biological processes are commentary on the tenacity of life. Or consider the possibility of incorporating actual fragments of asteroids, rich with pristine material from the dawn of the solar system, into sculptures and jewelry, turning a piece of cosmic history into a wearable, contemplative object. This moves chronicling from representation to incorporation, blurring the line between the chronicler and the cosmos itself, as we literally weave pieces of other worlds into our cultural tapestry. The very location of our galleries and archives is also destined to change. It's not a question of if, but when, the first art installation will be curated on another planet. Picture a dedicated gallery module within a future Mars habitat, its large viewports framing the rust-colored landscape outside, while inside, holographic and physical artworks respond to the real-time conditions of the Martian environment. Perhaps a soundscape that shifts with the pressure of an approaching dust storm, or a light installation that changes hue with the passage of Phobos and Deimos across the sun. These off-world chronicles will offer a perspective utterly unique to their location, created by artists who are experiencing the profound psychological shift of living on another world. Their work will not just be about space, it will be from space, offering a deeply human response to the ultimate frontier and creating a cultural record of our first steps as a multi-planetary species. Finally, the process of chronicling will become a living, breathing, and collective endeavor. We are moving towards crowdsourced digital chronicles that evolve in real time. Imagine an online, interactive map of the Milky Way that doesn't just display static data from a single mission, but continuously updates and grows as new observations stream in from professional observatories, amateur astronomers, and even citizen scientists classifying galaxies on platforms like Zooniverse. This living atlas would be a collaborative artwork in constant flux, its visualizations and sonifications adapting to incorporate the latest discoveries. A newly discovered exoplanet could be instantly rendered by a generative AI, its potential soundscape composed by a network of musicians, and its symbolic meaning discussed and debated in a global forum, all within hours of the initial scientific announcement. This transforms the chronicle from a finished product into an ongoing, participatory conversation, a global brain trust of artists, scientists, and enthusiasts collectively making sense of the universe as it reveals itself to us, piece by piece in real time. For thousands of years, humanity didn't have telescopes or satellites to explain the dazzling spectacle of the night sky. What we had were stories. Every culture on Earth looked up and wove narratives from the stars, creating intricate mythologies to explain the movements of the sun, the phases of the moon, and the sudden, terrifying disappearance of the sun during an eclipse. These were not mere fairy tales, they were the first cosmological models, born from careful observation and a deep need to find order and meaning in the cosmos. Today, a fascinating new dialogue is emerging, one where modern science doesn't dismiss these ancient stories but instead engages with them, using the tools of astronomy and archaeology to uncover the real celestial events that may have inspired them. This isn't about proving the myths true or false. It's about appreciating them as a profound form of human ingenuity and seeing how the collaboration between artists and scientists can breathe new life into these old tales, creating a richer, more layered understanding of both our past and our universe. Consider the famous Greek myth of Phaethon, the son of the sun god Helios, who loses control of his father's fiery chariot and plunges toward Earth, scorching the continents and turning Africa into a desert before being struck down by Zeus's lightning. For centuries, this was read as a classic cautionary tale about hubris, but some scientists and historians now propose a stunning astronomical interpretation. Around the end of the Bronze Age, roughly 1,200 years before the Common Era, geological evidence suggests a major climatic upheaval and widespread societal collapse across the Mediterranean. Could the Phaethon myth be a cultural memory of a real cosmic event? Some researchers point to the possibility of a massive airburst, similar to the Tunguska event in 1908, where a meteor or comet fragment exploded in the atmosphere, generating immense heat and a shockwave that could have been interpreted as a divine chariot crashing from the sky. By overlaying the mythological narrative with geological and astronomical data, the story transforms. It becomes a potential eyewitness account, passed down through generations, of a terrifying and inexplicable disaster written in the language of gods and heroes. This reinterpretation doesn't diminish the myth's power. It amplifies it, revealing a sophisticated attempt by our ancestors to process a real, traumatic event that literally fell from the heavens. This collaborative spirit between science and storytelling is powerfully alive today, especially in projects that seek to reconnect with and honor indigenous knowledge systems. For many First Nations cultures, the night sky is not a distant void but a living library, a detailed map of lore, and survival knowledge. Aboriginal Australian astronomy, for instance, is one of the oldest continuous cultural traditions on Earth, stretching back over 65,000 years. Their constellations are not simply pictures, they are narratives that dictate seasonal changes, signal when to harvest certain foods, and encode sacred creation stories known as the dream time. Modern astronomers are now working directly with Aboriginal elders to learn from this ancient wisdom. In one remarkable project, descriptions of a variable star in oral traditions, which speak of a spirit flame that flickers and fades, are being compared with the observed data of the star we call Betelgeuse. The correlation suggests a long-term observation of its dimming and brightening cycles, an astronomical discovery that Western science only made centuries later. This partnership is a two-way street. Scientists gain access to a deep time baseline of celestial observation, while indigenous communities see their cultural heritage validated and integrated into the global scientific narrative, often through beautiful artistic collaborations that map these ancient stories onto modern planetarium domes. Artists are the essential translators in this dialogue, taking these new, scientifically informed interpretations and rendering them into powerful, emotionally resonant experiences. They are creating stunning visual works that literally layer the old onto the new. Imagine a digital animation that begins with the familiar Greek constellation of Orion the Hunter, depicted in the classical style of a pottery painting. Then, as the animation progresses, the sketched lines of the figure dissolve into a breathtaking, high-resolution Hubble image of the Orion Nebula that lies within it, the swirling clouds of gas and dust glowing with ethereal light. The artwork doesn't say one vision is right and the other is wrong. It presents them as different layers of truth, the mythological and the astrophysical existing simultaneously. Or consider a musical composition that sonifies the precise orbital periods of the planets, and then weaves in ancient melodies or rhythms associated with those planetary gods, creating a symphony that is both mathematically accurate and spiritually evocative. These artistic projects do more than just illustrate, they perform an act of synthesis. They show us that the human impulse to tell stories about the cosmos and the scientific drive to understand its mechanics are not opposing forces. They are twin expressions of a single, enduring wonder, reminding us that every new discovery made by the James Webb Space Telescope is, in its own way, the latest chapter in a story that began when the first human looked up at the stars and felt the irresistible urge to explain them. But how do we actually perform this modern-day alchemy, turning the cold, hard numbers streaming from a telescope into something that feels almost like visual poetry? This process is known as data visualization, and in the hands of a skilled astronomer or scientific artist, it becomes a profound form of storytelling. At its heart, it's a translation exercise. A telescope like the James Webb doesn't capture images in color the way our eyes see. It measures light intensities at very specific wavelengths, often in the infrared spectrum, which is invisible to us. Each wavelength can reveal a different component of a cosmic object. One might highlight hot gas, another might show the distribution of dust, and another could pinpoint the location of specific molecules. The raw data is a set of numbers, a grid of pixel values for each separate filter. The artist's or scientist's first creative choice is in the color mapping. They assign a visible color to each of these invisible wavelengths. They might choose a fiery red for the longest infrared wavelengths and a cool blue for the shorter ones, not because those are the real colors, but because this particular palette creates the most scientifically informative and aesthetically harmonious composition. This is where the poetry begins, in the careful, deliberate choice of a color scheme that will reveal the hidden structure and drama within the numbers. The tools for this craft are as diverse as the cosmos itself, ranging from powerful, code-based scientific libraries to intuitive simulation software that feels more like a creative playground. For the data purist, programming languages like Python are the instrument of choice. Using libraries such as Astronomy for core astronomy functions, Matplotlib for basic plotting, and more specialized tools like APLPY for astronomical images, a scientist can write scripts that process gigantic FITS files, the standard format for astronomical data, and render them into precise, publication-ready visualizations. This code-based approach offers ultimate control, allowing a researcher to highlight a specific feature, subtract background noise, or combine datasets with pixel-perfect accuracy. It's a deeply technical and iterative process, a conversation between the scientist and the data, where each adjustment to the code can reveal a previously hidden jet of material flowing from a black hole or a faint, distant galaxy lurking in the background. On the other end of the spectrum, software like Universe Sandbox offers a more accessible and instantly gratifying form of cosmic visualization. This physics-based space simulator allows users to create and destroy solar systems, collide galaxies, and watch the evolution of the universe play out over billions of years in a matter of seconds. While it's often used for education and entertainment, its underlying engine is built on real gravitational physics and astrophysical principles. An artist or curious mind can use it to conduct thought experiments. What would the night sky look like from a moon orbiting Jupiter? What color would a sunset be on a planet with a methane atmosphere? By providing a sandbox to play with the variables of the universe, it empowers a new kind of intuitive, kinetic understanding of cosmic mechanics, turning abstract principles into visceral, visual experiences. The true masterpieces of this craft are the visualizations that manage to be both scientifically revelatory and breathtakingly beautiful. Consider the work done with the cosmic microwave background radiation, the faint afterglow of the Big Bang. The raw data from missions like Planck is a map of tiny temperature fluctuations across the entire sky, a seemingly random pattern of hot and cold spots that differ by mere millionths of a degree. To visualize this, scientists use a process called color mapping. They assign a vibrant color to each temperature value, transforming the subtle variations into a brilliant, full sky map that looks like a celestial dragon egg. This colorful image is not just pretty, it's arguably the most important cosmological dataset we have. Those patterns are the seeds of all future structure in the universe, the tiny density fluctuations that would, over billions of years, gravitationally collapse to form every galaxy, star, and planet we see today. The visualization makes this incredible story immediately apparent. It turns a dataset of minute temperature differences into a prophecy of cosmic creation. Another stunning example lies in the large-scale structure of the universe. When scientists map the positions of millions of galaxies, they don't find them randomly scattered. Instead, they form an intricate, web-like structure of dense clusters, long filaments, and vast, empty voids. This cosmic web is incredibly difficult to visualize in a static image because it's a three-dimensional construct. Data visualizers tackle this by creating immersive fly-through animations. Using the actual galactic coordinates from massive surveys like SDSS, they construct a three-dimensional model that we can journey through. The viewer soars past clusters of galaxies that look like dense, glowing knots of light, then travels along vast, faint filaments that connect them, before shooting across the breathtaking emptiness of a cosmic void. This visualization does what numbers on a page cannot. It gives us a gut-level understanding of the architecture of the universe. We don't just know about the cosmic web, we experience its scale and its structure. We see the fractal-like patterns that repeat from the largest scales down to the smallest, a signature of the gravitational forces that have shaped everything over cosmic time. This is the ultimate goal of data visualization in astronomy, to turn the abstract and the immense into something we can not only comprehend with our minds, but also feel with our senses, transforming petabytes of data into a visual poem about our place in the cosmos. We've explored how artists translate cosmic data into stunning visuals, but what if we could also listen to the universe? This isn't about science fiction sound in the vacuum of space. It's about a powerful technique called sonification, the process of converting data into sound. Scientists and artists are taking the same streams of information, the electromagnetic signals from distant stars, the ripples in space-time from colliding black holes, the rhythmic pulses of spinning pulsars, and translating them into an entirely new sensory experience. This practice opens up a hidden dimension of the cosmos, allowing us to hear patterns and rhythms that our eyes might never see, transforming abstract numbers into a symphony written by the universe itself. The process of sonification is a meticulous form of translation, much like assigning colors to different wavelengths of light in an image. Scientists take a dataset, for instance, the changing intensity of X-ray light from a black hole's accretion disk over time, and map its values onto sonic parameters. They might decide that the pitch of a note will represent the frequency of the light, so higher energy X-rays produce a higher musical tone. The volume could correspond to the brightness, growing louder as the black hole devours more material. Or the timing of the notes could be tied to the actual timeline of the event, allowing us to hear a celestial catastrophe unfold in real time. This isn't random musical composition. It's a direct, rule-based auditory representation of the data, creating a soundscape that is both scientifically accurate and strangely beautiful. It's a new language for understanding the mechanics of the cosmos. One of the most compelling examples of this is NASA's own black hole sonification project. The now famous pressure waves emanating from the supermassive black hole in the Perseus galaxy cluster were originally detected as data ripples in the hot gas that could be translated into a musical note. However, the note was about 57 octaves below middle C, far too low for the human ear to hear. Scientists and sound engineers then scaled the frequencies up by an astonishing factor of 288 quadrillion, bringing that deep cosmic hum into an audible range. The result is an eerie, haunting chorus of notes that seems to emanate from a place of profound darkness and power. It's a sound that feels both ancient and alien, giving us an immediate, visceral connection to one of the most extreme environments in the universe that bypasses our intellect and speaks directly to our emotions. But the applications of sonification extend far beyond creating atmospheric soundscapes. It's also becoming a valuable tool for scientific discovery. Our ears are exceptionally good at detecting subtle patterns, rhythms, and anomalies that can get lost in a visual graph crammed with data points. A researcher might listen to the sonified light curve of a star and immediately pick up on a slight, recurring dip in the melody, the auditory signature of an exoplanet transiting across its face. What might have taken minutes to identify by scanning a plot on a screen can be instantly recognized by the ear as a rhythmic, repeating pattern. This is especially powerful in the search for gravitational waves. The signals detected by LIGO and Virgo are incredibly faint whispers in the fabric of space-time. By converting these ripples into sound waves, scientists can literally hear the chirp, a rapidly rising tone that signifies the final, frantic moments before two black holes or neutron stars merge. This auditory approach allows them to quickly sort through vast amounts of data and identify potential cosmic events with an efficiency that complements traditional visual analysis. Beyond pure research, artists and composers are embracing this cosmic data as their muse, creating musical compositions that are grounded in the fundamental rhythms of the solar system. The concept of musica universalis, or the music of the spheres, is an ancient philosophical idea that the movements of celestial bodies create a form of inaudible harmony. With sonification, this idea is moving from metaphor to reality. Composers can take the precise orbital periods of the planets, the 88 Earth-year journey of Uranus, the 12-year orbit of Jupiter, and use them to create rhythmic structures or bass lines for a piece of music. The result is a form of music that is literally orchestrated by the laws of gravity and motion. Listening to such a composition is a profoundly different experience than looking at an orrery or a diagram of the solar system. It allows you to feel the grand, slow waltz of the gas giants and the quicker, tighter dance of the inner planets, all unfolding in a timescale that our minds can finally grasp and our bodies can feel. This auditory dimension to space exploration does more than just aid research. It forges a deeper, more intuitive connection to the universe, reminding us that we are not just observers of the cosmos, but participants in a grand, ongoing, and beautifully orchestrated cosmic performance. This powerful dialogue between art and the cosmos isn't just about looking outward. It's also about holding up a mirror, reflecting our own planet's fragility back at us through the lens of space. A new and urgent movement within cosmic art is doing exactly that, using the vantage point of the infinite to comment on the most pressing environmental issues right here on Earth. These artists are drawing powerful and often unsettling parallels between the pollution choking our planet and the new, human-made hazards we're beginning to export into the celestial realm. They ask a profound question: if we cannot be good stewards of our own world, what right do we have to expand our footprint into the solar system, and what responsibilities must we carry with us? Consider the growing crisis of orbital debris, often called space junk. There are now millions of pieces of human-made debris circling our planet: discarded rocket stages, defunct satellites, and fragments from past collisions, all traveling at speeds over 17,000 miles per hour. To science, this is a critical engineering and safety problem that threatens active satellites and the International Space Station. But to an artist, it becomes a potent symbol. The artist collective Forensic Architecture created a stunning visualization mapping the density and movement of this debris field, presenting it not as a technical problem, but as a planetary-scale environmental issue. Their work transforms anonymous data into a visible, swirling vortex of technological waste, a hauntingly beautiful yet terrifying portrait of humanity's first major artifact in space, a belt of garbage. This artwork forces a direct comparison to the Great Pacific Garbage Patch, making us see that our throwaway culture hasn't just polluted Earth's oceans and landscapes. It has now begun to pollute the orbital environment itself, suggesting a troubling pattern of behavior we seem destined to repeat. This theme of interconnected stewardship is powerfully embodied in the work of pioneering ecological artists like Agnes Deans. Her legendary 1982 work, Wheatfield: A Confrontation, was a profound act of land art. She planted and harvested 2 acres of golden wheat on a valuable landfill site in Lower Manhattan, right in the shadow of Wall Street and the World Trade Center. This wasn't just a pastoral scene in an urban jungle. It was a stark commentary on food, waste, land value, and human priorities. When we view this work through a cosmic lens, its meaning expands exponentially. That small, vulnerable, yet incredibly fertile patch of Earth becomes a stand-in for our entire planet, a fragile, life-giving oasis meticulously cultivated in a vast, inhospitable urban or cosmic desert. Deans didn't need to mention space. Her work inherently speaks to the preciousness of arable land, of a self-sustaining biosphere, and the immense effort required to nurture and protect it. It's a silent, powerful lesson in planetary management, reminding us that before we dream of terraforming Mars, we must first remember how to cherish and sustain the living world we already inhabit. Artist Tomas Sarasno takes this idea of interconnectedness and literally lifts it into the air, creating works that are both sculptures and visions for a sustainable future. His ongoing Aeroscene project is a community-focused endeavor that seeks to float sculptures and even people into the sky using only the heat of the sun and the air we breathe. No fossil fuels, no helium, no burnable propellants. His enormous, shimmering, solar hot air balloons are ethereal and beautiful, like giant jellyfish or celestial organisms drifting silently in the atmosphere. They represent a model of harmonious travel that leaves zero trace, working with atmospheric conditions rather than fighting against them with explosive rocketry. By doing so, Sarasno creates a tangible link between atmospheric protection on Earth and the principles of planetary protection in space. His work urges us to consider the ethics of our movement, whether we're traveling across an ocean or launching into the void. It proposes a new ethos for the age of exploration, that our journey into the cosmos must be guided by the same principles of sustainability and minimal impact that we are still struggling to learn here at home. We are being called to expand our definition of environment to include the solar system, to see the rings of Saturn as no less majestic and worthy of protection than the Grand Canyon, and to treat the pristine surface of Mars with the same reverence we should afford Antarctica. This artistic perspective fundamentally expands the scope of the Deep Space Chronicle. It's no longer just a record of what we observe and discover. It becomes a moral document, a guidebook for how we ought to proceed. It chronicles not only the wonders we find, but also the footprint we leave behind. These artists challenge the classic, exploitative narrative of space as a frontier to be conquered and mined for resources, and instead offer a vision of space as a commons, a shared heritage that requires careful, ethical stewardship from the very beginning. They ask us to look at the stars not with an attitude of conquest, but with a sense of profound responsibility, understanding that the same short-sightedness that created climate change on Earth could easily be repeated on a solar system scale if we do not change our approach. This fusion of environmentalism and cosmic art is perhaps one of the most vital contributions to the Chronicle, ensuring that our story among the stars is not one of repetition and regret, but of wisdom, foresight, and a deepened respect for the delicate balances that make life in any form possible. There is perhaps no greater artistic challenge than to paint the unpaintable, to give form to the formless, and to capture the sheer, overwhelming scale of the cosmos. This pursuit lies at the heart of a concept philosophers have long called the sublime, that unique and potent mixture of awe, terror, and transcendent beauty we feel when confronted with something vastly more powerful than ourselves, something that reminds us of our own profound smallness. For centuries, landscape painters have chased this feeling, depicting raging storms, fathomless chasms, and towering mountain ranges. But where does one even begin when the subject isn't a mountain, but the explosive death of a star larger than our entire solar system? This is the monumental task that space artists take on, using their craft to evoke the sublime and bring us, for a moment, face to face with the incomprehensible. We can trace this artistic lineage back to the 19th century Romantic painters like Albert Bierstadt, whose monumental canvases of the American West were never meant to be mere postcards. Works like Among the Sierra Nevada Mountains are masterclasses in the sublime. He used every tool at his disposal: dramatic lighting, exaggerated scale, and vast misty distances to make the viewer feel dwarfed by nature's grandeur. A tiny deer might sip from a lake that perfectly mirrors a sky filled with luminous, heavenly light, while colossal cliffs and waterfalls dominate the scene. Bierstadt wasn't just showing you a pretty place. He was creating an emotional experience designed to elicit a sense of reverent wonder and humbling insignificance. This is the exact same emotional palette that modern space artists draw upon. They are the spiritual descendants of these romantic painters, but their Yosemite Valley is the Horsehead Nebula, their Rocky Mountains are the rings of Saturn, and their golden sunlight is the violent, ultraviolet glare of a newly born star cluster. Digital artist and animator Eric Wernquist is a modern master of this cosmic sublime. His groundbreaking short film, Wanderers, is a perfect case study. It uses real astronomical data and locations within our solar system to create stunningly realistic visions of humanity's future among the stars. But the power of the film doesn't come from a narrative. It comes from the sheer scale and vertigo it induces. Wernquist doesn't just show us a space station orbiting Jupiter. He shows us a human figure, a tiny speck in a spacesuit tethered to that station, with the colossal, swirling marble of the gas giant filling the entire sky above them. The planet is so immense, its storm system so vast that the viewer instinctively feels a rush of awe and a pang of fear. It is beautiful, but it is also terrifyingly inhuman. In another sequence, people ice skate on the frozen surface of a moon, their skates sending up plumes of ice crystals that drift toward a breathtakingly thin ring arching across the blackness of space. Wernquist uses human figures not as heroes, but as benchmarks of scale, their fragile presence emphasizing the staggering, sublime grandeur of the environments they briefly inhabit. This artistic pursuit to capture the sublime is not so different from the core mission of science itself. Both are attempting to comprehend the incomprehensible. A physicist studying a supernova calculates the energy release in ergs, maps the distribution of heavy elements, and models the shock waves propagating through interstellar space. These are tools for understanding. An artist faced with the same event must ask a different set of questions. What would it feel like to witness that expanding sphere of light and energy from a nearby, safe vantage point? How can I convey the soundless, violent beauty of a star's death? How do I paint light that is brighter than a billion suns? The artist uses color, composition, and contrast to translate the physicist's data into an emotional and sensory experience. One gives us the facts of the event, the other gives us its soul. They are two sides of the same coin, both humbled by the phenomenon they are trying to describe, and both using their respective languages, mathematics and pigment, code and composition, to bridge the gap between human perception and cosmic reality. In this shared struggle, the sublime becomes a powerful common ground, a testament to the fact that our response to the universe's greatest wonders is a whole-body experience, one that engages not just our intellect but our deepest emotions. Yet for all the power of modern telescopes and simulations, they offer just one perspective, one way of seeing the cosmos, filtered through a specific scientific and cultural lens. But what if we could step outside that single viewpoint and see the sky through 1,000 different eyes? The truth is, we already can, because humanity's conversation with the cosmos has never been a monologue. It is a vibrant, global chorus of voices, each culture bringing its own unique stories, symbols, and wisdom to the act of interpretation. This incredible diversity of perspective doesn't detract from the scientific view. It profoundly enriches it, reminding us that understanding the universe is a collective human endeavor, and that every culture holds a piece of the puzzle. Consider the rich astronomical traditions of indigenous Australian cultures, whose connection to the land and sky stretches back over 65,000 years. In Aboriginal belief systems, the night sky is not a distant, separate realm. It is a living part of the dream time, the sacred era of creation. The stars, planets, and dark nebulae are not random points of light, but are intimately woven into the landscape and the lore. The emu in the sky, for example, is not a constellation of bright stars but a vast dark nebula, its shape outlined by the black patches of dust within the Milky Way. Its position in the sky throughout the year tells a story tied directly to the Earth. When it appears fully formed overhead, it signals the time when real-life emus are laying their eggs, guiding people to valuable food sources. This is astronomy deeply integrated with ecology, morality, and survival. A sophisticated, holistic knowledge system where the cosmos is a practical guide for living in harmony with the world. It's a perspective that challenges the Western separation of the heavens from the Earth, offering a model of interconnectedness that is both ancient and urgently relevant. Across the Pacific, the Navajo people of North America possess a similarly profound and practical celestial knowledge. Their cosmology is rich with stories that explain the order of the universe and humanity's place within it. For the Navajo, the star cluster known as the Pleiades is called Diliae, and its annual reappearance in the evening sky marks the beginning of the winter season, a critical signal for preparation and storytelling. But their understanding goes beyond simple observation. The layout of a traditional Navajo hogan, their sacred dwelling, is a microcosm of the universe, its door facing east to greet the rising sun, its circular shape reflecting the cyclical nature of time and the cosmos, and its structure aligned with specific celestial bodies. This architectural philosophy embodies a principle found in many indigenous knowledge systems, that the macrocosm of the universe and the microcosm of human life are mirrors of one another. To study the stars is to understand how to build a home both physically and spiritually. This is a form of cosmic interpretation that seamlessly blends the practical, the sacred, and the scientific into a single, coherent worldview. This global chorus is not confined to ancient traditions. It is alive and evolving today, with modern artists and scientists from diverse backgrounds actively reshaping how we see the cosmos. In Africa, a new generation of creators is drawing on both cutting-edge astrophysics and deep cultural heritage to produce stunning works of art. Sudanese-American artist Leila Amatolla Bahrain uses photographic collages to explore themes of identity and migration, often using celestial motifs to connect the African diaspora to a shared sky. Meanwhile, organizations like the African Planetarium Association are working to develop astronomy education and outreach that centers African perspectives, telling the stories of the stars as they are seen from the continent. They highlight, for instance, the cosmic origins of the iron in our blood, forged in the heart of a long-dead star, a concept that resonates powerfully with many African philosophies that emphasize our fundamental connection to the natural and cosmic world. This work challenges the often Eurocentric narrative of space exploration, asserting that the cosmos is humanity's common heritage and that its interpretation is immeasurably richer when it includes voices from all corners of the globe. When we bring these diverse cultural narratives into dialogue with Western science, something magical happens. We don't discard the data from the Hubble or Webb telescopes. We simply place it within a larger, more nuanced framework of human meaning. A Western astronomer might look at the Pleiades and see a young open star cluster, estimating its age and composition. A Navajo elder might look at Dilier, Hay, and see a story about perseverance and the changing seasons. Both views are valid, both are true. Together, they create a multidimensional understanding that is far more complete than either could be alone. The scientific data gives us the physical mechanics, the how. The cultural stories often give us the why, the human significance, the moral, the connection to our lives on this planet. This multiplicity of thought is not a weakness, it is our greatest strength. It allows for a more flexible, creative, and ultimately more humane approach to the great mysteries of the universe, ensuring that our chronicle of the cosmos is not a single, narrow thread but a magnificent, multicolored tapestry woven from the wisdom of all humanity. While giant observatories and space agencies capture headlines, some of the most heartfelt and surprising contributions to our cosmic chronicle come from a different source entirely: the dedicated army of amateurs and hobbyists whose passion for the night sky is matched only by their creative ingenuity. These are the backyard astrophotographers who spend countless freezing nights patiently collecting photons from a distant galaxy, the watercolor artists who set up their easels under a blanket of stars, and the tinkerers who build their own radio telescopes from spare parts. They may not have advanced degrees or access to billion-dollar budgets, but what they possess is something equally vital: an unbridled curiosity and a deeply personal connection to the cosmos that often leads to breathtaking art and genuine scientific discovery. The tools of this democratic revolution are more accessible than ever before. A modern consumer-grade telescope, coupled with a dedicated astronomical camera and a computerized mount, can now fit on a small patio and capture images that would have rivaled those from professional observatories just a few decades ago. The magic happens through a technique called long-exposure imaging, where the camera's shutter is left open for minutes or even hours at a time, gathering faint light from objects millions of light-years away. This process is an act of patience and artistry in itself. The raw image that comes off the camera is often a grainy, monochrome mess. The true artistry begins at the computer, where the astrophotographer uses specialized software to carefully calibrate, stack, and process dozens or hundreds of these individual exposures. They gently stretch the data to reveal hidden details, balance colors based on the known chemistry of the nebula, and painstakingly reduce noise, all to produce a final image that is both scientifically informative and stunningly beautiful. The result is not just a picture, it's a labor of love that transforms abstract data into a personal encounter with a distant cosmic wonder. This solitary pursuit is powerfully amplified by the global communities that have sprung up online, transforming individual hobbyists into a collaborative network. Platforms like Cloudy Nights forums, the AstroBin image hosting site, and countless Facebook groups serve as virtual clubhouses where enthusiasts from every corner of the world share techniques, troubleshoot equipment failures, and celebrate each other's successes. It is within these digital spaces that collaboration often sparks innovation. An astrophotographer in Arizona might share a new processing technique that reveals faint dust structures in a galaxy, which is then adopted and refined by an imager in Australia. A visual artist might browse these galleries for inspiration, then contact the photographer to ask for permission to use their image as a reference for an intricate oil painting. These connections blur the lines between disciplines, creating a feedback loop where scientific data inspires art, and that art, in turn, inspires others to look more deeply at the science. A particularly stunning amateur image of a comet can go viral on social media. capturing the public's imagination in a way that a dry press release never could, and reminding millions that the universe is accessible to anyone who cares to look up. The impact of this community extends far beyond creating pretty pictures for social media likes. Amateurs regularly make contributions that directly advance our scientific understanding. With their countless hours of dedicated observing time, they are perfectly positioned to notice when something changes. It was an amateur astronomer in Japan, for instance, who first spotted a new outburst on the surface of Jupiter, alerting the professional community to train their large telescopes on the event to study the aftermath of a likely asteroid impact. Variable star observing, the meticulous tracking of stars that brighten and dim over time, is a field heavily reliant on data collected by amateurs around the globe, providing crucial long-term datasets for professional researchers. In the realm of art, amateur painters and digital artists often possess a fresh, unencumbered perspective, creating compositions and using color palettes that a professional illustrator working on a tight deadline might not attempt. Their work, shared freely online, expands the visual vocabulary we use to imagine the cosmos, pushing the boundaries of how we see and represent these distant realms. This flourishing of creativity and citizen science fundamentally proves that the drive to chronicle the cosmos is a universal human impulse, not a privilege reserved for an elite few. It ensures that the narrative of space exploration remains grounded in wonder and passion, qualities that can sometimes be squeezed out of large, institutionalized science by budget constraints and bureaucratic pressures. The amateur, by definition, does what they do for the love of it. Their astrophotographs are infused with the thrill of capturing a faint whisper of light from another galaxy. Their paintings are filled with the emotion of a quiet night spent under the stars. This raw, authentic passion is infectious, drawing new people into the fold and fostering a more inclusive and vibrant community. The story of the universe is simply too big, too beautiful, and too important to be told by only a handful of voices. It requires a chorus, a global community of passionate observers and creators, each adding their unique perspective, their patient data, and their artistic vision to our collective, ever-evolving Deep Space Chronicle. If the vast, swirling colors of a nebula or the precise orbit of a planet can be translated into art, then what about the invisible, counterintuitive, and utterly bizarre rules that govern reality itself at its very smallest scales? This is the frontier where quantum physics and abstract art collide, a partnership that seems unlikely on the surface but feels almost inevitable upon closer inspection. After all, how do you depict a world where a particle can be in two places at once, where objects become inextricably linked across vast distances, and where the simple act of observation changes the outcome of an event? You cannot paint an electron, you cannot sculpt a probability wave. To explore this realm, artists must abandon representation entirely and venture into the domain of pure abstraction, using shape, color, and form not to depict reality, but to evoke its underlying mysterious nature. Long before the Copenhagen interpretation or Schrödinger's famous cat became topics of scientific debate, a Swedish artist named Hilma af Klint was already channeling these concepts onto canvas from a place of deep spiritual and intellectual inquiry. Beginning in 1906, she created a series of massive, non-representational paintings called the Paintings for the Temple, which she believed were dictated to her by a higher consciousness. These works, featuring swirling geometric forms, bold symmetrical diagrams, and a vibrant, symbolic palette, were utterly unprecedented at the time. They depict a universe of dualities and unities, circles split into light and dark, spirals suggesting evolution and growth, and forms that seem to be both particle and wave simultaneously. Af Clint was not illustrating quantum theory. She was accessing a similar intuitive understanding of a reality that is interconnected, fluid, and beyond our ordinary perception. Her work, hidden from the world for decades, now appears as a stunningly prescient visual language for concepts physics would only later struggle to define, proving that the artistic impulse to map the invisible dimensions of existence has been with us all along. Contemporary digital artists continue this exploration with even more sophisticated tools, creating immersive experiences that plunge us directly into the feeling of quantum weirdness. Imagine stepping into an installation where you are surrounded by swirling projections of light. These are not random patterns, they are visualizations of quantum superposition, the principle that a particle exists in all possible states until it is measured. The artist might use a constantly shifting, probabilistic cloud of points to represent an electron's potential locations, never settling on one, forcing you to sit with the discomfort and the beauty of uncertainty. In another piece, you might encounter two shapes or fields of color that react to each other instantly, no matter how far apart they are in the room, a direct visual metaphor for quantum entanglement, that spooky connection Einstein famously disliked. This is art that doesn't try to explain the math. It lets you experience the emotional and philosophical weight of these ideas. It makes the profoundly abstract feel tangible, creating a gut-level understanding that bypasses the need for complex equations and speaks to a more intuitive way of knowing. This powerful synergy between the quantum physicist and the abstract artist reveals something fundamental about how we grapple with the limits of our own understanding. Science provides the mathematical framework and the experimental proof for these phenomena, but it often struggles to convey their meaning or their visceral impact. This is where art becomes an essential partner, providing a toolkit of metaphors. A physicist might describe the quantum vacuum not as true emptiness, but as a seething foam of virtual particles popping in and out of existence. An artist like James Turrell takes that concept and turns it into a physical experience with his skyspaces, where viewers sit in a room and gaze at a perfectly framed rectangle of open sky. Over time, as your eyes adjust, the blue of the sky begins to feel less like a distant ceiling and more like a palpable, shimmering substance, a field of potentiality, deep and vibrating and alive. It doesn't explain quantum field theory, but it makes you feel in your bones that what looks like nothing is actually teeming with invisible activity. This is the unique gift of art, to provide metaphors that allow us to hold two contradictory ideas in our minds at once, to be comfortable with mystery, and to approach the most counterintuitive truths of our universe not with frustration, but with a sense of expanded wonder. Think about the last time you were truly captivated by a scientific discovery. Chances are, it wasn't just the raw data that hooked you, it was the story wrapped around it. We are a species hardwired for narrative. Our brains don't just process information, they crave context, conflict, and resolution. This innate love for a good story is the secret weapon behind the most effective Deep Space Chronicles, transforming complex data and distant phenomena into compelling, emotional journeys that we can't help but follow. It's the difference between reading a technical manual on rocketry and feeling the heart-pounding suspense of Apollo 13. Both convey information, but only one makes you lean in, makes you care, and makes you remember. This deliberate use of narrative structure is masterfully employed in landmark documentaries that have defined public understanding of the cosmos. Take Carl Sagan's original Cosmos, A Personal Voyage. The series wasn't a simple lecture, it was an epic narrative where humanity itself was the protagonist on a grand adventure of discovery. Sagan didn't just tell us the universe was vast, he crafted a story arc that began with our earliest ancestors gazing at the stars and culminated in our tentative first steps into the solar system, with the Voyager probes carrying our message to the stars. He used the classic device of a hero's journey where we, the collective human spirit, faced the unknown, acquired new knowledge, our magical tool, and returned transformed with a new responsibility for our pale blue dot. Neil deGrasse Tyson's reboot, Cosmos: A Space-Time Odyssey, doubled down on this technique, introducing a fictional ship of the imagination as a narrative vehicle. This wasn't just a visual effect, it was a storytelling device that allowed the audience to be passengers on a journey through time and space, making abstract concepts like the scale of the cosmic calendar a visceral, experiential voyage. The narrative frame turned viewers from passive recipients of facts into active participants in an epic. This power of storytelling extends far beyond the screen into the pages of graphic novels and books that chronicle space missions. Andy Weir's The Martian is a brilliant case study. While a work of fiction, its immense popularity and subsequent film adaptation succeeded because it presented real science within an incredibly gripping narrative structure. The story of astronaut Mark Watney is a classic survival tale, a man-against-nature story set on the most alien environment imaginable. Each chapter presents a new problem: how to make water, how to grow food, how to communicate, and the resolution is always founded on real chemical, botanical, and physical principles. The narrative doesn't feel like a textbook because the science is seamlessly woven into the plot. It's the hero's tool for overcoming each obstacle. Readers aren't being taught orbital mechanics. They are desperately hoping Watney can calculate a rendezvous trajectory to save his life. The emotional investment in the character's survival makes the underlying science not just palatable, but thrilling and unforgettable. Even the communication of actual missions leverages these techniques. When NASA Jet Propulsion Laboratory live streams the 7 minutes of terror during a Mars landing, they aren't just providing a technical readout. They are consciously crafting a real-time thriller. The mission controllers become the characters we root for. The plummeting spacecraft is the protagonist facing seemingly insurmountable odds. The entry, descent, and landing sequence is the gripping third act, with each milestone parachute deployment, heat shield separation, sky crane maneuver serving as a plot point building towards the climax of touchdown confirmation. The scientists and engineers narrate the event with rising and falling tension, their voices reflecting the anxiety and hope of the situation. This framing transforms a complex automated procedure into a shared human drama, watched by millions who hold their breath together, waiting to see if the story will have a happy ending. It's live, participatory storytelling that forges a powerful emotional connection between the public and the mission, turning taxpayers and observers into passionate stakeholders in the narrative's success. The reason this approach is so effective boils down to cognitive psychology. Stories provide a framework for memory. Information presented within a narrative structure is more easily encoded and recalled than a list of disjointed facts because it gives the brain a schema, a sequence of connected events with cause and effect. We remember how the story made us feel, and the facts are anchored to those emotions. A dry statement about the composition of Saturn's rings is forgettable. But a story about how those rings are the remnants of a shattered moon, torn apart by the planet's gravitational tides billions of years ago, creates a vivid mental image of a dramatic celestial event. It provides context, a reason for being that makes the information stick. By framing cosmic exploration not as a collection of data points but as an ongoing saga of curiosity, perseverance, and discovery, these chronicles do more than just inform. They inspire a sense of wonder and belonging. inviting every one of us to see ourselves as part of the greatest story ever told, the story of our universe and our place within it. But as we push the boundaries of our imagination to envision life beyond Earth, we must also confront a profound responsibility. The way we choose to depict alien organisms isn't just a creative exercise, it's an ethical one, shaping public perception and potentially even influencing the future of scientific exploration. For centuries, our visions of extraterrestrials have been overwhelmingly anthropocentric, that is, filtered through a human-centric lens. From the bug-eyed Martians of pulp magazines to the humanoid aliens that dominate Hollywood, we have consistently imagined the other as a reflection of ourselves, often with just a different number of eyes or a change in skin tone. This tendency is understandable. We are, after all, prisoners of our own perception, and our brains are wired to seek out familiar patterns. But it's also a profound limitation, one that risks blinding us to the truly staggering diversity of forms that life might take in the universe's infinite variety of environments. This is where the fledgling science of astrobiology provides a crucial ethical and creative framework. Instead of starting with a blank canvas and pure imagination, responsible artists and scientists now begin with first principles of chemistry, physics, and biology. They ask foundational questions rooted in real science. What is the solvent on this world? On Earth, life is water-based, but on a frigid moon like Titan, life might use liquid methane or ethane. That simple change has cascading effects. A methane-based biochemistry would operate at much slower rates and at far colder temperatures, potentially leading to creatures with incredibly slow metabolisms and life cycles spanning millennia. What is the energy source? Instead of photosynthesis using our sun's light, life in the dark ocean of Enceladus might rely on chemosynthesis, drawing energy from hydrothermal vents on the seafloor, which could give rise to entire ecosystems in perpetual darkness, perhaps relying on sonar or sensing minute changes in pressure rather than sight. By grounding their speculation in these astrobiological principles, creators move beyond mere fantasy and into the realm of plausible, informed possibility. This approach doesn't stifle creativity. It channels it, leading to visions of alien life that are far more strange, wonderful, and intellectually satisfying than any simple humanoid could ever be. The influence of science fiction on public expectations cannot be overstated, and with that influence comes a significant ethical weight. For generations, films and television have served as the primary source of the public's understanding of space and alien life. When a blockbuster movie depicts first contact as a violent invasion, it reinforces a narrative of fear and hostility. When aliens are consistently shown as monsters to be defeated, it subtly prepares us for conflict rather than collaboration. Conversely, a film like Denis Villeneuve's Arrival presents a radically different and more ethically considered model. The heptapods in that film are truly alien. Their body plan is utterly non-humanoid. Their written language is a complex, non-linear system, and their perception of time is completely different from our own. The film's central conflict isn't about defeating them, but about the painstaking, humble effort to understand them. It makes the audience sit with the discomfort of incomprehension, and in doing so, it teaches a vital lesson. That communication with a truly advanced intelligence would be an immense challenge requiring patience, empathy, and a willingness to fundamentally change our own way of thinking. This kind of thoughtful storytelling does more than entertain. It ethically prepares us for a potential future reality, encouraging a mindset of curiosity and respect over fear and aggression. This commitment to responsible depiction is also vital within the scientific community itself. Exobiologists and astrobiologists who speculate about alien life in academic papers have a duty to clearly distinguish between what is known, what is theoretically possible based on established science, and what is sheer speculation. When a scientist publishes a paper on the potential for silicon-based life forms or discusses the hypothetical biologies that could exist in the hydrocarbon lakes of Titan, they are engaging in a necessary and valuable thought experiment. But they must frame it as such to avoid headlines that prematurely announce the discovery of silicon life or mislead the public. This careful navigation of the line between inspiration and misinformation is a core tenet of scientific ethics. It ensures that public excitement is built on a foundation of genuine knowledge rather than sensationalism, protecting the credibility of science while still allowing it to dream big and inspire wonder. The most compelling chronicles of potential alien life are those that embrace the unknown with both excitement and integrity, inviting us to wonder at what might be out there while remaining honest about the fact that we have yet to find a single example beyond our own planet. Look up at a photograph of the Orion Nebula, and you'll see a magnificent cloud of gas glowing with vibrant pinks, deep reds, and ethereal blues. It's a breathtaking sight, but it invites a fascinating question. If an astronaut could fly right up to that nebula and look out the window, would they see those same spectacular colors? The surprising answer is often no, and that reveals one of the most intricate dances between art and science. Our eyes are remarkable, but they are limited instruments, especially in the extreme low-light conditions of deep space. The cameras on telescopes like Hubble and Webb, however, are not limited in the same way. They act as incredibly sensitive light collectors, gathering photons over hours or even days across specific wavelengths, many of which are completely invisible to the human eye, such as infrared and ultraviolet light. The raw data they send back isn't a finished picture. It's a set of numbers, a scientific dataset waiting to be translated into something we can see and feel. This is where the artist steps in, not as a mere decorator, but as a crucial interpreter, using the fundamental principles of physics to guide their choices and create an image that is both scientifically truthful and profoundly beautiful. The most important tool in this translation process is spectroscopy, the science of breaking down light into its constituent wavelengths to understand its source. Every element in the universe has a unique spectral fingerprint. Hydrogen, the most abundant element in nebulae, glows most strongly in a specific shade of red when it's energized by nearby stars. Oxygen, on the other hand, emits a greenish-blue light. Sulfur shows up as a deeper red. The telescope's filters can isolate the light from each of these individual elements, creating separate grayscale images, one that shows only the hydrogen, one for oxygen, one for sulfur, and so on. The artist's first critical decision is to assign a visible color to each of these invisible or faint wavelengths. A common approach, known as the Hubble palette, assigns sulfur to red, hydrogen to green, and oxygen to blue. When these grayscale images are then combined, the resulting composite reveals the nebula's complex structure and chemical composition in a single, stunning image. The colors are representative, not literal. They are a map, a code that allows us to see the separate ingredients that make up the cosmic cloud, teaching us about its composition and the powerful stellar forces shaping it. This process of color mapping also powerfully conveys temperature and motion, two properties that are central to understanding cosmic objects. Consider the Doppler effect, the same principle that makes a siren's pitch change as it races past you. In light, this effect causes a shift in color. An object moving toward us has its light waves compressed, shifting it toward the blue end of the spectrum. An object moving away has its light stretched, shifting it toward red. Artists can use this principle to visualize the incredible dynamics within a galaxy or the explosive outflow from a dying star. In an image of a spinning galaxy, subtle gradients of blue on one side and red on the other can illustrate its rotation in a way that is instantly understandable. In a supernova remnant, vibrant blue hues might highlight the hottest forward shock material racing toward us, while deep reds show the cooler, expanding shell moving away. This artistic application of physics turns a static picture into a dynamic story, allowing us to witness the motion and energy of events that unfolded millions of years ago. Ultimately, this work requires a delicate and ethical balancing act. The goal is never to deceive, but to illuminate. The artist must walk a fine line between scientific fidelity and aesthetic impact. They might slightly enhance the contrast to make a faint filament of dust more visible, or choose a color palette that highlights the dramatic interaction between two colliding galaxies, but they do so based on the real data, not fantasy. The resulting image is a form of visual journalism. It reports the facts, but does so with an eye for composition and drama that makes the story compelling. This careful collaboration gives us the best of both worlds, the rigorous truth of science and the emotional resonance of art. It allows us to learn that a nebula is primarily composed of ionized hydrogen and dust, while simultaneously feeling a sense of awe at its sublime beauty, a reminder that the universe's truths are not just written in equations, but painted across the void in a brilliant palette of light. Perhaps the single greatest challenge in chronicling the cosmos is one of sheer magnitude. How do you possibly convey the reality of a distance so vast that light itself takes years to cross it, or a time span so long that it dwarfs the entirety of human civilization into a fleeting blink? These concepts, light years and billions of years, are mathematical abstractions that our brains, evolved to navigate a world of meters and minutes, are fundamentally unequipped to grasp. This is where the artist becomes an essential translator, devising ingenious techniques to bridge the chasm between human perception and cosmic reality, transforming incomprehensible numbers into experiences we can feel in our bones. One of the most effective tools in this endeavor is the logarithmic scale. To a scientist, a logarithmic plot is a practical way to display data that spans many orders of magnitude on a single page. But to an artist, it becomes a profound narrative device. Imagine trying to draw the solar system to scale on a piece of paper. If you make the Earth a mere peppercorn, Neptune would be a marble over a football field away, and the nearest star, Proxima Centauri, would be another peppercorn located over 6,000 miles away. A linear model is useless. Instead, artists and visualizers create interactive experiences that use a logarithmic zoom. You might start with an image of a person lying on a blanket, looking up at the stars. With a click, you zoom out to see the Earth, then the solar system, but the zoom function isn't linear, it's exponential. Each click multiplies the view by a factor of 10. The planets whip past in a blur. The solar system collapses into a single point of light almost instantly, and the Milky Way galaxy first appears as a structure, then as a mere speck itself, all within a dozen clicks. This controlled, exponential zoom mimics the way our own understanding expands, allowing us to mentally navigate these dizzying scales without becoming completely lost. It's a visual metaphor for the layered nature of the universe, where every time you think you've seen the biggest picture, there's an even grander scale waiting just beyond. When it comes to time, the challenge is even more profound, as we lack any physical movement to guide us. Billions of years is a number, but it carries no weight. Artists tackle this by creating condensed timelines that map the universe's entire history onto a relatable human scale. A classic technique is to compress the 13.8 billion year age of the universe into a single calendar year. The Big Bang happens at the first second of January 1st. Our solar system doesn't form until early September. Dinosaurs evolve in late December and go extinct on the 26th. All of recorded human history from the first cities to the present day occupies the final mere seconds of December 31st, just before the clock strikes midnight. This isn't just a clever analogy, it's a conceptual anchor that delivers a visceral, humbling punch. It recontextualizes our entire existence, not as the main event, but as the very last footnote in a very long story. This artistic framing is experientially transformative. It doesn't just tell you the universe is old, it makes you feel the breathtaking depth of time that preceded us, a duration so vast it can only be understood through poetic compression. For the ultimate immersive experience, artists and programmers combine these techniques into powerful interactive tools that hand control over to the viewer. The seminal digital project, The Scale of the Universe 2, by Kerry and Michael Huang, is a masterclass in this approach. It presents a horizontal scroll bar at the bottom of the screen, but this is no ordinary slider. As you drag it, the view smoothly zooms through over 60 orders of magnitude, from the infinitesimal Planck length to the entirety of the observable universe. You can stop at any point, and the interface provides labels and context for what you're seeing. You can zoom in to see a human hand, then keep going to explore individual skin cells, molecules, atoms, and subatomic particles. Then you can zoom back out past the hand to the Earth, the solar system, the galaxy, and beyond to the cosmic web of galaxies. The genius of this tool is its seamless, continuous flow. There are no jarring cuts. The transition from a coffee bean to the planet Jupiter is as smooth as sliding a knob. This interactivity is key. It transforms the viewer from a passive recipient of information into an active explorer. The act of physically controlling the zoom, of deciding the pace of your journey, creates a deep, personal sense of the connectivity of scale. You aren't just being told that a virus is smaller than a cell. You are performing the action of zooming in to see it for yourself, building a muscle memory for the architecture of reality itself. These artistic techniques do far more than just illustrate facts. They perform a kind of cognitive alchemy. They take the cold, hard data of astronomy and transmute it into a form of wisdom. A logarithmic scale teaches us humility. A cosmic calendar teaches us perspective. An interactive, zoomable universe teaches us connectivity. They allow us to internalize the sublime truth that the hydrogen atoms in our bodies were forged in the heart of a long-dead star, and that the light from the Andromeda galaxy hitting our eyes tonight began its journey when our ancestors were just learning to walk upright. By making the abstract tangible, these artistic methods don't just help us understand the universe's dimensions, they help us find our place within them, transforming overwhelming data into a profound and personal sense of wonder. It's a common assumption that the relationship between art and science is a one-way street, that scientists make a discovery, and then artists are brought in to create a pretty picture for the press release. But this vastly underestimates the power of the artistic lens. In a fascinating reversal of that traditional flow, there are numerous cases where the creative, intuitive work of artists has directly sparked new scientific questions, revealed hidden patterns in data, and even identified errors in complex models. This isn't about art simply decorating science. It's about art actively participating in the scientific process, serving as a unique and powerful tool for discovery. One of the most compelling examples of this lies in the study of fluid dynamics within nebulae. These vast clouds of gas and dust are not static. They are chaotic, turbulent systems where stellar winds, radiation pressure, and magnetic fields all interact in incredibly complex ways. Scientists use supercomputers to run sophisticated simulations of these environments, but the raw output is often just a massive, multi-dimensional dataset, a collection of numbers representing density, velocity, and pressure at millions of points. Visualizing this data is not a trivial afterthought. It is an essential part of the analysis. Scientific visualizers and artists take these numbers and assign colors and textures to them, turning the abstract math into a dynamic, flowing visual simulation. In doing so, they are making choices about which variables to highlight and how to represent them. A choice to make a specific turbulence pattern a vivid orange against a blue background might be an aesthetic decision, but it can have a profound scientific consequence. That very choice might make a previously unnoticed vortex or instability suddenly pop out, visible for the first time. The artist's eye, trained to see pattern, form, and flow, can detect a subtlety that the scientist, focused on the numerical values, might have initially overlooked. This new visual insight can send the researchers back to their code, asking new questions. What physical force is causing that helical structure? Why is that shockwave breaking in that particular way? The artwork becomes a hypothesis generator, a visual question that demands a mathematical answer. This process of visual discovery extends beyond the digital realm and into the physical. Consider the work of the late artist-turned-astronomer, José Francisco Salgado. Initially trained as a photographer and digital artist, Salgado began creating stunning multimedia works that paired his astronomical imagery with classical music. To ensure his visuals were scientifically accurate, he developed deep collaborations with astronomers at institutions like the Adler Planetarium and NASA. In one project focused on simulating the Martian atmosphere, Salgado was working with data from a global climate model of the Red Planet. As he began to render the movement of dust storms across the Martian globe, his artistic sensibility for motion and texture led him to create a visualization that was not just accurate but intuitively graspable. Scientists who saw his work noticed features in the flow and global circulation patterns that their standard two-dimensional plots and graphs had failed to convey with the same clarity. His artistic translation of the data provided a different perspective on the same information, offering a holistic view that made complex atmospheric dynamics easier to understand and, crucially, to question. The art didn't replace the data, it reframed it, allowing for a more nuanced interpretation of the planet's weather systems. Perhaps one of the most direct examples of an artistic medium leading to a scientific insight involves something as simple as a handmade ceramic glaze. Astronomer and artist Susan Murabana works in Kenya, co-founding the Traveling Telescope Initiative to bring astronomy education to rural communities. In her artistic practice, she creates beautiful pottery inspired by the cosmos, using traditional techniques and local materials. The process of creating glazes, mixing minerals and chemicals, applying them to clay, and firing them in a kiln is a hands-on science experiment. The results are unpredictable and deeply physical. This tactile engagement with materials and chemical reactions offers a form of understanding that is completely different from theoretical astrophysics, yet it is no less valid. While this might seem separate from her astronomy work, this kind of embodied knowledge, the understanding of how materials behave under extreme heat and pressure, can subtly inform how one thinks about the formation of planets and asteroids, which are, in essence, cosmic ceramics forged in the kiln of the early solar system. This kind of cross-pollination is harder to quantify than a software visualization, but it demonstrates how the artist's mindset, one of experimentation, observation, and acceptance of beautiful accidents, can foster a unique form of creativity that enriches scientific thinking. The reciprocal relationship is clear. Science provides the framework of laws and constants, while art provides the freedom to explore, visualize, and question within that framework, often leading everyone involved to see the old data with brilliantly new eyes. Yet this profound encounter with the scale of the cosmos does more than just humble us. It can also open a door to a different kind of understanding, one that is less about measurement and more about meaning. This is the realm where cosmic art transcends the scientific and ventures into the spiritual and philosophical, inviting us to contemplate not just what the universe is, but what it means for our existence within it. For millennia, humans have looked to the stars to ponder the biggest questions. Why are we here? Do we have a purpose? Are we alone? Modern cosmic art continues this ancient tradition, using the visual language of nebulae, galaxies, and infinite space to create modern secular temples, spaces for meditation on infinity, consciousness, and our fragile, fleeting place within the grand sweep of cosmic time. Consider the monumental works of German artist Anselm Kiefer. His paintings are not pretty, romanticized views of the night sky. They are vast, textured, and often somber landscapes that feel both ancient and apocalyptic. He applies thick layers of paint, strews ash, lead, and even dried flowers across his massive canvases, creating surfaces that are as much archaeological digs as they are paintings. When he depicts a star field, it is not the clean, glittering pinpoints of a Hubble image. His stars are often suggested by specks of light barely emerging from a dark, thick, and turbulent ground of material. These works feel heavy with time and memory. They don't offer easy answers about our place in the universe. Instead, they evoke a powerful sense of mystery and melancholy. Looking at a Kiefer, you are confronted with the sheer weight of cosmic history and the ephemeral nature of human endeavor. His art becomes a meditation on creation and decay, on the fact that the very atoms that make up our bodies were forged in the deaths of stars, and that one day we will all return to that cosmic dust. It's a spiritual experience that is deeply rooted in a material, scientific reality, asking us to find meaning not in an afterlife, but within this breathtaking and transient cosmic cycle. A completely different, yet equally profound, approach to creating a spiritual encounter with the cosmos is found in the work of American artist James Turrell. For over half a century, Turrell has used light itself as his medium to challenge our very perception of reality. His most famous projects are his skyspace's seemingly simple rooms with a precisely framed rectangular opening cut directly into the ceiling, open to the sky above. Viewers are invited to sit in silence within these chambers and simply watch. As you sit, your eyes adjust, and the sky itself begins to transform. The blue doesn't look like a distant ceiling anymore. It starts to feel close, palpable, almost like a thin, luminous veil or a liquid field of color that you could almost touch. Passing clouds seem to be moving within the frame of the ceiling, not beyond it. Turrell removes all context. There are no trees, no buildings, no horizons, leaving you with nothing but the raw experience of light and space. This enforced, contemplative focus induces a state that can only be described as meditative or even mystical. Your sense of depth and solidity dissolves. The sky ceases to be a thing out there and becomes an experience in here within your own consciousness. A skyspace doesn't preach a doctrine. It creates the conditions for a personal, wordless revelation about the nature of perception and our intimate, physical connection to the cosmic light show happening above us every single day. This powerful intersection of art, science, and spirituality is crucial because it addresses a fundamental human need that data alone cannot satisfy. Science excels at answering how questions how a star forms, how a galaxy evolves, how the universe expands, but it remains silent on why questions why is there something rather than nothing. Does our existence have a purpose? Cosmic art provides a vital bridge, a space where we can hold these questions without demanding a definitive answer. It allows us to engage with the universe soulfully, to feel the emotional and philosophical weight of scientific discovery. A data plot of the cosmic microwave background is intellectually fascinating, but a beautifully rendered map of it, glowing like a cosmic mandala, can feel like staring into the face of creation itself, sparking a sense of awe that borders on the religious. This engagement is not a retreat from rationality, it is an expansion of it. It acknowledges that we are not just thinking machines, but feeling beings who crave meaning and connection. By deepening our personal, emotional connection to the cosmos, this art transforms our understanding from a dry academic exercise into a vibrant, lived experience. It helps us see that we are not just observers of the universe, but active participants in its ongoing story, and that our quest for meaning is itself a beautiful and integral part of the cosmic chronicle. This incredible shift from passive observation to active participation is perhaps one of the most exciting developments in how we chronicle the cosmos, transforming the public from an audience into a co-creator. The era of space exploration being a distant spectacle conducted solely by a select few in lab coats is rapidly fading, replaced by a new model of open, collaborative discovery where anyone with an internet connection can roll up their sleeves and contribute to genuine scientific and artistic endeavors. This movement, often called citizen science or crowd-sourced creation, is fundamentally democratizing our relationship with the universe, proving that you don't need a PhD to help write the next chapter in humanity's greatest story. At the forefront of this revolution is the Zooniverse platform, a magnificent digital agora where millions of everyday people become classified as planetary cartographers and galactic archivists. The premise is brilliantly simple yet profoundly powerful. Projects like Galaxies Zoo present volunteers with real, often never before seen images from telescopes like Hubble. The task isn't to possess pre-existing expertise, but to employ a skill we all share, pattern recognition. You are asked to look at a galaxy and classify its shape. Is it a smooth ellipse, a majestic spiral, or something more peculiar? This might seem like a small act, but the collective power is staggering. When thousands of people examine the same image, their aggregated classifications produce data that is incredibly accurate and reliable. This human-powered analysis has led to genuine scientific discoveries, including the identification of entirely new classes of galaxies and the serendipitous finding of Hanny's Voorwerp, a mysterious and enormous green gas cloud discovered by a Dutch schoolteacher named Hanny van Arkel. Her story is a testament to the power of this model, a curious individual armed with nothing but a laptop and her innate curiosity can literally stumble upon a cosmic mystery that captivates professional astronomers for years. But the collaboration doesn't stop at classification. The spirit of shared creation is now expanding into the artistic realm, inviting the public to lend their ears and their creative instincts to the cosmos. Consider a project that takes the orbital data of a newly discovered near-Earth asteroid, its speed, its rotation, its trajectory, and translates those numerical values into a musical scale. The pitch of notes could represent the asteroid's velocity, the rhythm its spin, and the volume its proximity to Earth. This raw data-driven melody is then released to an online community of musicians, producers, and even hobbyists with a digital audio workstation. They are invited to use this cosmic score as a foundation to compose, remix, and interpret the asteroid's journey through sound, One musician might layer it with ambient, ethereal synths, evoking the loneliness of space. Another might build a driving, percussive track around it, mirroring the relentless motion of a rock hurtling through the void. The result is not a single, authoritative piece of music, but a crowd-sourced symphony of interpretations, each one offering a different emotional and artistic perspective on the same scientific data. This process transforms a cold, statistical orbital diagram into a shared cultural artifact, a collective emotional response to a piece of our solar system. The driving force behind this movement, from NASA citizen science campaigns to university-led initiatives, is a profound understanding that democratizing the process fosters a powerful and lasting sense of shared ownership. When you spend an afternoon classifying galaxies on Zooniverse, you aren't just helping scientists, you are developing a personal stake in that data. You might find yourself checking back on a particular galaxy you classified, curious about its official designation or what further research has revealed. You become invested. Similarly, when your musical composition is featured in a planetarium show based on asteroid data, your connection to that celestial object is forever changed. It's no longer just a nameless rock, it's your asteroid, the one you composed a song for. This emotional investment is the most valuable currency for the future of space exploration. It builds a broad, deep, and passionate base of public support that understands the value of discovery not as an abstract concept, but as a personal achievement. It creates a global community that sees itself as part of the mission, ensuring that the chronicle of the cosmos is written not by a single author, but by a chorus of millions of voices, each adding their unique note to the grand and ongoing symphony of discovery. What began as a pursuit of pure wonder has now blossomed into a vibrant and complex marketplace, a testament to how deeply these cosmic chronicles resonate with our collective consciousness. The business of space art is no longer a niche corner of the art world. It's a dynamic ecosystem encompassing everything from multi-million-dollar auctions to digital storefronts, each playing a crucial role in sustaining the artists and institutions that bring the universe to our eyes and hearts. Perhaps the most iconic moment that signaled this shift into the mainstream was the Christie's auction in 2021, which featured a collection of 24 photographs taken by NASA astronauts. These weren't just prints, they were unique digital files certified by a non-fungible token, or NFT, and they sold for over $300,000. The star lot was a breathtaking image of the Earth rising over the lunar horizon, captured by Dr. William Anders during the Apollo 8 mission. This sale did more than just generate headlines. It fundamentally reframed space photography as a unique genre of fine art, worthy of preservation and investment, and established a new commercial pathway for the very astronauts who had witnessed these views firsthand. This commercial energy isn't confined to the rarefied air of auction houses. A thriving gallery scene has emerged, with physical and virtual spaces dedicated exclusively to cosmic art. Galleries like the Coconino Center for the Arts in Arizona host annual Cosmos exhibitions, while online platforms like the Cosmic Gallery and the Space Art Store connect artists directly with a global audience of enthusiasts. These venues showcase an astonishing diversity of work. You can find traditional oil paintings of Martian sunsets hanging alongside intricate sculptures inspired by dark matter and large-scale light installations that mimic the behavior of pulsars. This commercial support is vital. It provides artists with the financial means to continue their work, funding the materials, software, and time required to translate complex data into compelling visuals. When a collector purchases a piece, they aren't just buying a decoration, they are directly funding the next chapter of the chronicle, enabling the artist to delve deeper into new discoveries and share them with the world. The rise of digital NFT art has introduced a fascinating and controversial new dimension to this market. For digital artists who work primarily in pixels and code, the blockchain offers a way to create scarcity, prove ownership, and receive compensation for their often ephemeral work. Artists like Black Box have created stunning, algorithmically generated nebulae that exist solely as digital tokens, while collectors can now own a unique piece of data visualization art from missions like the James Webb Space Telescope. This technology has democratized collecting in one sense, allowing anyone with a cryptocurrency wallet to own a slice of cosmic art, and it has created a new revenue stream for a younger generation of digitally native creators. However, it also raises profound questions about accessibility and the environmental impact of blockchain technology, potentially creating a new barrier for those who wish to engage with the art on a meaningful level. This tension between commercialization and pure wonder lies at the heart of the modern space art economy. On one hand, the market amplifies public engagement dramatically. A high-profile auction generates media buzz that reaches far beyond typical art circles, introducing millions to the beauty of cosmic imagery. The sale of an NFT can fund an artist's residency at an observatory, leading to new works that might not have been possible otherwise. This cycle of creation, sale, and further investment ensures that the chronicle continues to grow and evolve. Yet, there is a valid concern about the commodification of the cosmos itself. Does putting a price tag on a digital file of a nebula, a phenomenon that has existed for millions of years, somehow diminish its majesty? Could the drive for commercial success push artists toward more sensational or trendy subjects, rather than following their own authentic curiosity? These are not easy questions, but they are essential to the ongoing dialogue about how we value and support the human impulse to interpret the universe. Ultimately, this bustling marketplace, for all its complexities, proves that there is a deep and abiding hunger for these connections. It reveals that art is not just a passive output of science. It is a sustainable force that fuels its own engine of wonder, ensuring that our chronicles of the cosmos can be created, shared, and preserved for generations to come. But this vital work of preservation faces unprecedented new challenges in the digital age. Unlike a centuries-old star chart on vellum, a modern digital file of a nebula is incredibly fragile. File formats become obsolete, storage media degrades, and the very bits of data that make up a breathtaking image can be lost to what archivists call digital rot. Initiatives like the NASA Planetary Data System are pioneering solutions, using rigorous format standards and creating multiple redundant copies stored in geographically diverse locations to combat this threat. They treat each digital image from a rover or telescope not as a temporary file, but as a priceless cultural artifact, ensuring that the raw data behind our most iconic space images remains accessible and usable for centuries, not just years. This is digital archaeology for the future, a conscious effort to prevent a digital dark age where our greatest cosmic chronicles become unreadable bits on a forgotten hard drive. Perhaps the most poetic and ambitious expressions of this preservative impulse are the time capsules we have launched into the cosmos itself. The Voyager Golden Record is the ultimate example, a literal chronicle of Earth intended for an audience of the distant future, human or otherwise. Curated by a team led by Carl Sagan, it wasn't just a collection of data, it was a work of art and a profound philosophical statement. The selection of music, from Bach to Chuck Berry, the sounds of rain and a mother's kiss, and the encoded images of life on Earth were all carefully chosen to tell a story of our planet's beauty, diversity, and creativity. The golden record transcends its physical form as a gold-plated copper disc. It is a message in a bottle cast into the cosmic ocean, a deliberate attempt to preserve a snapshot of human culture and extend our chronicle beyond our own planet and potentially beyond our own species. This idea of an off-world archive is now evolving into more permanent and ambitious projects. Plans for lunar libraries involve etching vast amounts of information from the entire Wikipedia to human genetic codes onto ultra-durable nickel plates and depositing them in permanently shadowed craters on the Moon, where they could potentially survive for millions of years. The goal is to create a backup of human knowledge, a resilient time capsule that could outlast civilization itself. These initiatives are driven by a powerful dual purpose. They are both a practical safeguard for our collective knowledge and a profound symbolic act. By placing our chronicles on another world, we are making a declaration about the importance of our story, asserting that the human experiment with all its art, science, and curiosity is worthy of remembrance on a geological timescale. It is the highest form of conservation, ensuring that even if our time on Earth is finite, the record of our wonder might just echo through the cosmos for eons to come. Yet for all the power in this collaboration, there exists a crucial and often delicate boundary, a line where the interpretive freedom of the artist must gracefully yield to the unwavering demands of scientific fact. This is not a limitation on creativity, but a necessary ethical commitment to truth, especially when the work is presented in an educational context or has the potential to shape public understanding on a massive scale. The most responsible creators in this space understand that their work operates within a sacred trust. They are translating wonder, not inventing it, and the distinction is everything. When an artist takes liberties with the scale of a planet to make a more striking composition, or amplifies the colors of a nebula to highlight its chemical structure, they are working within an accepted realm of enhancement. But when that liberty fundamentally misrepresents a core scientific principle, the art risks ceasing to be a gateway to understanding and instead becomes a source of enduring misconception. We can see the real-world impact of this tension in some of the most dramatic public misrepresentations of cosmic phenomena. Consider the pervasive imagery of black holes as cosmic vacuum cleaners, relentlessly sucking in everything around them with a terrifying, inescapable force. This is a dramatic oversimplification that has been reinforced by decades of science fiction. In reality, a black hole's gravity is no different than that of a star of the same mass. If our Sun were somehow replaced by a black hole of equivalent mass, Earth's orbit would remain completely unchanged. The intense gravitational effects only become extreme once you cross the event horizon. This vacuum cleaner trope is a classic case of artistic sensationalism overshadowing scientific nuance, and it has created a persistent public misunderstanding that astrophysicists must continually work to correct. Similarly, many visualizations of our solar system are wildly out of scale, compressing the mind-boggling distances between planets to fit on a screen or a page. While this is often a practical necessity, without clear disclaimers it can leave viewers with a completely false impression of the profound emptiness that defines our cosmic neighborhood, inadvertently diminishing one of astronomy's most important lessons about scale. The guidelines for navigating this divide are not about stifling creativity, but about fostering a culture of transparent and responsible creation. The cornerstone of this approach is a commitment to clear labeling and context. A piece of artwork depicting an exoplanet should ideally be accompanied by a brief explanation of what is known the star type, the planet's estimated size and orbit, and what is speculative, such as the color of the vegetation or the structure of any hypothetical life forms. This honesty doesn't break the spell of wonder, It enhances it, inviting the audience into the scientific process and showing them where the solid ground of discovery ends and the thrilling landscape of imagination begins. Furthermore, artists have a responsibility to engage in genuine collaboration, to move beyond using scientists as a mere fact-checking service, and instead involve them in the creative dialogue from the very beginning. This partnership ensures that the artistic choices are informed by the latest research and that the final work, while imaginative, remains anchored in plausibility. This critical perspective is what ultimately protects the integrity of the entire endeavor. It ensures that our chronicles of the cosmos remain trustworthy, that the public can look at a stunning visualization and feel confident that it is built upon a foundation of real evidence. This trust is the bedrock upon which public support for science is built. When that trust is broken by a knowingly inaccurate depiction designed solely for shock value or clicks, it erodes the credibility of all scientific communication. The goal is not to eliminate imagination, but to channel it responsibly. The most powerful space art exists in that beautiful, fertile zone where the known facts of science provide the trellis upon which the vines of imagination can grow in a supported and truthful way. It uses its creative power not to distort reality, but to reveal its hidden wonders, providing a vision of the universe that is both faithful to the evidence and expansive to the human spirit, ensuring that our sense of wonder is always paired with a grounded and genuine understanding. Sometimes the most profound journeys begin not with a giant leap, but with a single, breathtaking image. Consider the story of a young girl who stumbled upon a poster of the pillars of creation in her local library. To her, it wasn't just a cloud of gas and dust, it was a celestial cathedral, a frozen moment of creation that sparked a fire of curiosity she never knew she possessed. That one encounter, that fusion of scientific discovery and artistic grandeur, set her on a path. She devoured books on astronomy, saved for a telescope, and eventually pursued a degree in astrophysics. Today, she's part of a team analyzing data from the James Webb Space Telescope, her career a direct testament to the transformative power of a single piece of cosmic art. Her story is far from unique. It echoes in the experiences of countless individuals for whom the Deep Space Chronicle was not a passive observation, but a personal call to action. This transformative power extends beyond inspiring future scientists. It can also reignite passion and provide solace for those already in the field. A researcher buried in the isolating grind of data analysis and grant proposals might find themselves facing a crisis of purpose, the vastness of their work feeling abstract and disconnected. Then they attend a planetarium show or see an artist's rendition of the very phenomenon they're studying, to see their complex data translated into a soaring symphony of light and sound, to witness the raw emotional impact it has on an audience of strangers, is a powerful reminder of why they began this work in the first place. It reconnects them to the wonder that drew them to astronomy, transforming their perspective from one of isolated focus to one of shared human experience. This rekindling of passion is a vital function of the Chronicle, serving as a beacon that guides professionals through periods of doubt and reminds them that their calculations and equations are part of a larger, deeply human story of exploration. For many others, the impact is not on their career path, but on their entire worldview and emotional resilience. A person grappling with personal loss or feelings of insignificance might find unexpected comfort in the Hubble Ultra Deep Field image. While some might expect the sheer scale of the universe to be a source of terror or existential dread, for them, it becomes a source of profound peace. The image of thousands of galaxies, each containing billions of stars, doesn't make their problems feel small in a diminishing way, but rather places them within a context of breathtaking grandeur. Their personal struggles, while real and important, are part of a cosmic tapestry so vast and majestic that it inspires a sense of perspective and humble connection. This shift in worldview, from a narrow focus on individual concerns to a more expansive view of our place in the cosmos, can be a powerful source of hope and healing, offering a form of cosmic therapy that is both humbling and uplifting. The Chronicle also possesses a remarkable ability to build bridges across generations and cultures, creating shared moments of awe that transcend language and background. A grandparent who once watched the Apollo moon landings on a grainy television might now sit with their grandchild and explore the surface of Mars through a virtual reality headset. Together, they share the same gasp of wonder as they navigate the rust-colored canyons of Valles Marineris. This shared experience, mediated by stunning artistic visualization, becomes a cherished memory and a point of connection. It transforms the cosmos from a subject in a textbook into a common ground for storytelling, curiosity, and bonding. The Chronicle becomes a family heirloom of sorts, a shared language of wonder that is passed down, ensuring that the innate human desire to explore and understand the universe continues to thrive in the hearts of the next generation. Ultimately, these personal testimonials reveal that the deepest value of the Deep Space Chronicle may not lie in the facts it conveys, but in the feelings it evokes and the actions it inspires. It serves as a mirror reflecting our own potential back at us, a catalyst for curiosity that can alter the trajectory of a life, and a source of comfort that can reshape a worldview. Whether it's the aspiring astronaut, the reinvigorated scientist, the individual finding solace, or the family forging a connection, each story underscores the same fundamental truth: our engagement with the cosmos is not a passive hobby. It is an active, deeply personal dialogue that has the power to heal, to motivate, to connect, and to remind us that we are all, every single one of us, active participants in an ongoing, billion-year story of cosmic evolution and wonder. And so our journey through the Deep Space Chronicles draws to a close, but the story itself is far from over. We began with that single, awe-inspiring image from Hubble, a universe of galaxies contained within a speck of sky, and we've traveled through time and technology to understand how humanity makes sense of such immensity. What we've discovered is that the most profound interpretations of the cosmos occur not when art and science stand apart, but when they walk hand in hand, each lending its unique language to a shared conversation about our place in the universe. This powerful fusion does more than just produce beautiful pictures or accurate data. It transforms the cold, abstract vastness of space into something accessible, emotionally resonant, and deeply, wonderfully human. We've traced this partnership back to its ancient roots, where cave paintings and celestial myths were humanity's first attempts to chart the heavens, and followed it through the Renaissance, where masters like Leonardo da Vinci saw no distinction between careful observation and creative expression. We witnessed how modern science relies on artistic visualization to translate the invisible from the fiery ring of a black hole to the potential landscapes of distant exoplanets into forms we can see and understand. We saw how raw data itself becomes a muse, inspiring symphonies from stellar vibrations and vast cyanotypes from galactic structures, engaging our senses in ways pure numbers never could. This historical synergy reveals a timeless truth, that our urge to chronicle the cosmos is as fundamental as our need to breathe, a drive to find both meaning and beauty in the patterns of the night. Beyond wonder, we've seen the immense educational power of this union, how a well-crafted animation can make Einstein's relativity intuitive to a child, or how a citizen science project can turn a global community into active cosmic cartographers. We've grappled with the ethical responsibilities that come with this power, acknowledging the fine line between inspiring wonder and creating misinformation, and the importance of representing both alien life and our own planetary footprint with integrity and care. And we've dared to look forward to a future where artificial intelligence becomes a creative partner, where bioart incorporates extraterrestrial materials, and where immersive virtual reality allows us all to walk on distant worlds, making the cosmos a place we can visit, not just observe. This entire journey underscores one central, hopeful idea: that the universe is not a distant spectacle for a select few with advanced degrees. It is a shared inheritance, a story that belongs to all of us. The Chronicle is written in planetarium shows and online galleries, in the meticulous data of a space probe and the passionate brushstrokes of a backyard painter. It lives in the ancient stories of the Navajo and the Aboriginal Australians, and in the cutting-edge algorithms of a digital visualizer. You don't need a telescope to contribute to this grand narrative. Your engagement can take any form that sparks your curiosity. Visit a museum and stand before a painting that tries to capture the sublime. Pick up a book that retells the Greek myths with modern astronomical insights. Simply step outside on a clear night, away from the city lights, and look up, gaze at the stars, and let your own imagination fill in the gaps. What stories do you see written in those constellations? What questions does the silence of the infinite spark in you? Every single one of those questions, every moment of awe, every sketch, photograph, or story you share becomes a vital part of the ongoing Deep Space Chronicle. You are adding your voice to a conversation that spans millennia and bridges disciplines. You are helping to write the next chapter in humanity's greatest story, ensuring that our collective interpretation of the cosmos continues to grow richer, more diverse, and more filled with wonder for all who will gaze up at the stars after us. But this journey doesn't have to end here. This is where our shared exploration truly begins. We've traveled from the earliest star maps to the farthest reaches of digital imagination, and now we want to hear your story. What piece of space art has left you breathless? Was it a classic painting of swirling nebulae, a haunting sonification of a distant pulsar, or perhaps a photograph you took yourself from your own backyard? Drop your stories and your favorite links in the comments below. Let's build a living gallery of wonder together, a community chronicle of the cosmos shaped by your curiosity. Your perspective is a unique star in this constellation of ideas, and by sharing it, you help all of us see the universe in a new light. If these kinds of mysteries and revelations fuel your imagination, make sure you're following along for our next adventure into the unknown. We're constantly exploring the intersection of science, art, and the profound questions that lie at the edge of our understanding. To make sure you never miss a journey, hit that subscribe button and ring the bell so you're notified the moment our next video goes live. There are so many more cosmic stories waiting to be told, from the secrets of dark matter to the future of interstellar travel, and we want you right there with us as we continue to interpret the universe together. Most importantly, we want to extend a sincere thank you for spending this time exploring the Deep Space Chronicles with us. Your engagement and curiosity are what make this entire endeavor so meaningful. Remember, the story of the universe is not a closed book written by a select few. It is an ever-evolving narrative, a living tapestry of discovery that each of us helps to weave every single time we look up in wonder, ask a question, or share a moment of awe. You are not just an observer of this grand chronicle, you are an active participant, a vital voice in the ongoing, billion-year-old conversation between humanity and the cosmos. Keep